Hello there and welcome to the Sleepumentary channel. Tonight we begin, not with an answer, but with a breath. A slow one, the kind that loosens the grip of the day, the kind that reminds you that you're here, in a small corner of a vast universe, listening to stories that stretch far beyond the reach of our hands. Welcome to this quiet journey, where science is not a set of facts, but a soft lantern guiding us through the darkness. Even after centuries of discovery, the universe still feels overwhelmingly young to our understanding. We've mapped spirals of galaxies whose light began traveling toward us before humans learned to speak. We've traced the faint glow of ancient radiation, the soft after-sound of a hot newborn cosmos. We've watched particles smaller than dust flicker in and out of existence, behaving in ways that defy the logic of the world we see. Every breakthrough feels like a step forward, and yet every step reveals another staircase disappearing into the dark. It's strange, isn't it? How the more we learn, the more mysterious the universe becomes, as if reality were a book with most of its pages soaked in shadow. We turn one page and instead of answers, we uncover half-formed clues, questions that lead to deeper questions and whispers of phenomena that stretch the limits of imagination. For every discovery, dark matter, dark energy, quantum fields, cosmic expansion, 10 new mysteries emerge behind it. Nature guards its secrets well, but it also leaves them scattered like breadcrumbs waiting for curious minds to follow. Tonight we follow those breadcrumbs together, but unlike the hurried pace of daytime science, the equations, the debates, the experiments, this journey moves slowly, gently, sleepily. We're not racing towards certainty. We're drifting through possibility, letting curiosity soften instead of sharpen. Science in these late hours becomes a lullaby, a reminder that you don't need to solve everything to feel wonder. You only need to look up or inward and allow yourself to be surprised. So settle into your pillow, let your shoulders fall, let your breath find its own rhythm. Feel the room grow a little quieter, as if the universe itself were lowering its voice to speak. Because here is the truth. No matter how powerful our telescopes become, no matter how deeply we peer into the fabric of space-time, there will always be regions of the universe forever hidden from us. We live inside a bubble of light, an expanding sphere shaped by the finite speed of photons and the relentless stretching of space. Beyond its edge lie worlds we will never see, galaxies forming right now whose light will never touch our retinas, stars burning with no witnesses, entire cosmic dramas unfolding in silence. Humanity has mapped oceans, continents, planets, the moons of Jupiter, the plains of Mars. But space laughs softly at the idea of being mapped. It folds, stretches, twists, and expands so quickly that even perfect instruments, even infinite time would never reveal its full shape. You're lying here listening, wrapped in blankets, while somewhere billions of light years away a star is collapsing into a black hole. Somewhere else a galaxy is forming its first stars. Somewhere further still, far beyond the reach of any light, a universe-sized region exists with physical laws slightly different from ours. Maybe atoms there are unstable. Maybe stars never ignite. Maybe matter forms patterns we would not recognize. And all of that is happening right now. It's humbling, comforting, a little dizzying. A reminder that our existence is both tiny and extraordinary. Science tells us that even the concept of time, something we treat as steady and reliable, may not behave the way we think. What if time is not a river flowing smoothly forward, but a surface that bends, stretches, and ripples? What if the first moment of the universe wasn't a beginning at all, but a transition from something stranger? What if our familiar world is just one small expression of a much deeper reality? But don't worry, we're not here to wrestle with those questions. We're here to float beside them, to let them drift through our thoughts like gentle waves in a dark ocean. You don't need to grab onto them. Just notice how wide the world becomes when you allow mystery to have a place. Tonight as you rest, the universe continues moving. Stars orbit, galaxies collide, quantum particles flicker with silent determination. Space expands in every direction, stretching the distances between clusters of galaxies faster than any ship could ever travel. And in the middle of all that, you're here breathing. There is something peaceful about recognizing how vast everything is. Something soothing about the idea that you don't need to understand it all. You're allowed to let go, to drift, to listen. So let the day slip away now. Let curiosity stay awake even as your body grows still. Let the unknown surround you like a dark, gentle sea, and when you're ready, we'll step deeper into that sea, part by part, mystery by mystery, allowing wonder to guide us through the quiet. When we talk about the universe, we often imagine it as something we could one day map an enormous but finite territory, waiting patiently to be charted. But the truth is far stranger and far more humbling. We live inside a boundary that is not physical, but woven from light and time themselves, a kind of cosmic shoreline beyond which we can never wade. No matter how powerful our telescopes become, no matter how sensitive our instruments grow, certain regions of the universe will remain forever hidden behind an expanding curtain of distance and speed. The universe has a limit not in size but in visibility, a horizon, the cosmic horizon. Right now, as you lie in your quiet room, the universe is expanding outward, and light moves at its unyielding pace. This creates a beautiful but sobering truth. There are galaxies so far away that their light has not had enough time to reach us since the beginning of the cosmos. Their photons have been running toward us for billions of years, and they will never arrive. Space stretches faster than the light can cross it, pulling everything farther apart with every second that passes. Imagine standing on a beach at night. You can see the water just close enough for the moonlight to catch it, shimmering silver across the surface. But beyond that shimmer, beyond a certain darkness, the ocean disappears. Not because it ends, but because your eyes cannot reach any further. That's what we live inside a moonlit circle on a shoreline stretching endlessly into the black. The rest of the water, we know it's there. But no light reflects back to us from those distant depths. The universe is full of unread chapters, entire volumes that will never grace our cosmic library. We turn the pages available to us in the observable universe, but beyond that horizon, the story continues in silence. Galaxies rise, form, stars collapse, collide. Worlds orbit suns we will never know existed. Patterns of matter unfold without the faintest whisper of their presence crossing into our bubble of visibility. And the strangest part, our bubble isn't still. It's growing, and so are the regions beyond our reach. Space expands like bread dough, rising in all directions. The distances between clusters of galaxies increase faster than any vessel, signal, or particle could hope to cross. Even if we launched a perfect spacecraft, even if we waited for trillions of years, there are regions of the universe that will forever drift away faster than we can chase them. In that sense, we live inside a cosmic snow globe. Everything we can ever observe, every galaxy, every beam of radiation, every whisper of ancient light exists inside this shimmering boundary. Outside it lies a silent universe, unreachable, not because it is closed off, but because the rules of reality place it perpetually beyond our grasp. Picture it this way: if the universe were a great library stretching into eternity, we would be reading only a single floor, a single wing, a single shelf of books. The rest of the shelves are real full of stories written in the light of distant suns, but they remain sealed, their pages glued shut by the expansion of space. There's something oddly comforting in that thought. The idea that the cosmos is larger than we can ever know. That reality exceeds us in every direction. We are tiny readers in an immeasurable archive, yet our little shelf still holds so much wonder. Science tells us that beyond the visible universe, matter could arrange itself into shapes and structures never seen. In some places, cosmic filaments might stretch in configurations that defy our models. Entire superclusters might swirl in patterns that no human imagination has ever conjured. And in those distant regions, physics might dance to familiar rules or shift subtly in ways we can't verify or witness. Gravity might weave galaxies differently. Stars might ignite in ways that contradict our astrophysical expectations. There may be silent galaxies whose light will never reach us. Whole cosmic civilizations of matter and energy that exist outside our time and visibility. Grand events happening this very moment in realms we will never behold. And yet none of this diminishes what we can see. Our cosmic island is rich, vast, and breathtaking. The known universe is already more expansive than our minds can comfortably hold. But knowing that there is more, so much more, lifts the imagination. It gives us permission to dream beyond the edges of our knowledge, to feel awe without needing ownership of every cosmic secret. As you relax and listen, picture the horizon not as a barrier, but as a soft line where known and unknown meet. A place where imagination is invited to wander freely, where physics whispers that mystery is not an enemy, but a companion. You are here in your room wrapped in the calm of the night. But your mind is drifting far beyond the Milky Way, beyond the cosmic web, beyond even the regions light can touch. You're floating at the edge of the horizon, looking out across an ocean without end. Somewhere in that unreachable distance, a star is being born. Somewhere else, a galaxy is growing old. And in between, across billions of light years, stories unfold silently, patiently, forever unread. The universe is vaster than light can describe, vaster than time can reveal, vaster than any map a human hand will ever draw. And still, it welcomes you to wonder. When we look at the night sky, it is tempting to imagine that every glowing point follows the same rules we do, that physics is universal, unchanging, and absolute. But the deeper we explore, the more we find hints that our familiar laws might be only one dialect spoken in a much larger cosmic landscape. The universe, vast beyond comprehension, may not be a single uniform story. It may be a patchwork of chapters written in different languages of physics, some similar enough to understand, others utterly foreign. Modern cosmology entertains a provocative possibility that the values we consider constants, the mass of particles, the strength of forces, the properties that allow atoms to form and stars to ignite may not be fixed everywhere. They may vary across enormous stretches of space, each region emerging from the early universe with slightly different parameters, like cosmic islands shaped by distinct initial conditions. Imagine that. Travel far enough far beyond our horizon, farther than light can carry us, and the universe might begin to change. In one domain, gravity might be stronger, in another weaker. In one realm, electrons might be heavier, in another lighter. In one patch of reality, atoms might cling tightly together, while in another they might barely hold at all. These are not small tweaks. They are the difference between a cosmos filled with stars and galaxies and a cosmos that is silent, dark, and barren. Let's drift through a few possibilities. Picture a region where the strong nuclear force, the force that holds atomic nuclei together, is just a little weaker. Not by much. A tiny shift barely noticeable in an equation. But in that domain, the universe would never form stable hydrogen. Without hydrogen, there are no stars, no fusion, no light. Just an endless sea of matter, too shy to ignite, drifting in eternal cold. Now imagine the opposite, a universe where the strong force is too strong. In that realm, hydrogen fuses too easily. Stars ignite violently, burning through their fuel in mere thousands of years. Too brief for planets to cool, too brief for chemistry to settle, far too brief for life to emerge. A cosmos of fireworks, dazzling but fleeting. Or consider a universe where the electromagnetic force is slightly altered. Atoms might not bind into complex molecules. Chemistry as we know it simply wouldn't exist. No water, no carbon chains, no proteins, no life. Reality would be reduced to a swirling fog of incompatible particles that never learn how to dance together. There could be domains where gravity is so faint that galaxies never form, and others where gravity is so fierce that every region collapses into black holes before stars can be born. Some pockets of existence might look almost like ours, familiar galaxies, suns, planets, while others are dominated by phenomena we have no words for. Perhaps matter forms crystalline lattices stretching across light years. Perhaps energy behaves like fluid tides, ebbing and flowing across dimensions we cannot perceive. Perhaps stars never shine at all, replaced by slow-burning structures made of particles unknown to our physics. When scientists speak of fine-tuning, they mean this. Our universe appears to sit on a razor's edge of possibility. The constants of nature fall into an extraordinarily narrow window, narrow enough for long-lived stars, stable atoms, complex chemistry, and ultimately consciousness. If the numbers had differed by even a fraction, none of this would be here. Not galaxies, not planets, not life, not the quiet moment you're experiencing right now. Fine-tuning is not necessarily intentional. It may be simply the result of probability across vast cosmic diversity. If countless regions exist, each with different constants, then it is not surprising that at least one of them, ours, happened to form under conditions that allow observers to arise and ask questions. Still, the idea carries an emotional weight. It means that the laws we treat as fundamental, unchanging, perfect, absolute, may be local customs rather than universal truths. That our atoms, our chemistry, our entire existence might be an example, not a rule. There is something deeply humbling in that, something intimate. It suggests that we belong to a specific cosmic neighborhood, one that happens to host long-burning stars, stable molecules, and the gentle, improbable conditions that give rise to minds capable of reflection. We live in a universe where starlight lasts long enough to warm planets, where carbon weaves itself into delicate structures, where water can flow and freeze and evaporate. It didn't have to be this way. In most imagined universes, the story ends before it begins. When you think of it like that, the night sky becomes even more precious. Every star is not just a burning sphere of gas, it is a testament to a narrow set of numbers that had to align for anything luminous to exist. The cosmic constants are the strings of a delicate instrument tuned so precisely that the slightest shift would silence the entire song. Somewhere beyond the cosmic horizon, there might be regions where the music never starts, realms where atoms fall apart the moment they form, regions where chemistry dissolves into chaos, domains where light cannot exist because nothing can ignite, silent universes, dark universes, vast chapters of creation filled with quiet, unlit matter. And yet in our little patch of reality the notes came together. Stars formed, galaxies spun, planets cooled, life emerged, consciousness awakened and began to wonder. As you rest tonight, consider this. The universe may be immense, strange and divided into countless domains, but you inhabit one where starlight warms worlds, where atoms hold steady, where life has the chance to flourish. This tiny region of possibility, this sliver of existence with just the right constants, is where your story unfolds. And that is not just science. It is something close to a miracle, whether mathematical or metaphysical, accidental or profound. If you close your eyes for a moment and imagine the beginning of everything, your mind may naturally drift toward a single point, a bright flash, a sudden spark, an explosion of light and heat. We call it the Big Bang, though the name is misleading. It wasn't an explosion inside space, it was space. It wasn't a burst of matter inside time. It was the moment time itself began its long, quiet unfolding. And yet, every part of us still wonders what was before that. This question sits at the intersection of science and longing. Humans have always tried to trace stories back to their beginnings, our families, our histories, our species, our planet. It's natural to look for a first page, a first note, a first push that set everything into motion. But when we apply that instinct to the universe, the rules grow fuzzy. The equations that describe reality break down as we rewind time closer and closer to that primordial moment. Patterns become meaningless, values diverge. Like a map ending abruptly at the edge of the known world, our mathematical tools simply stop. Still, scientists are not content to leave the boundary unexplored, so they look for ways to peer behind the veil using the faintest whispers of ancient light, the distribution of galaxies, and the subtle ripples frozen into the cosmic microwave background as clues. One idea imagines that before the expansion we call the Big Bang, the universe may have been contracting, slowly gathering itself, compressing matter and energy, until reaching a critical point. Instead of collapsing into a true singularity, perhaps it bounced, reversing direction and launching into expansion. Like a cosmic inhale followed by an exhale. If this is true, then the Big Bang was not a beginning at all, but a transition, the middle chapter of a far older cosmic cycle. In such a universe, time would not start or stop. It would loop through ages of growth and collapse, each era leaving faint imprints on the next. Scientists search for such imprints, tiny scars, subtle asymmetries in the oldest light we can observe. Patterns that seem slightly too orderly or slightly too uneven could hint at processes that occurred before the earliest moment our equations can describe. Another proposal imagines that time itself is not fundamental, that what we call before may not even make sense at the deepest layers of reality. In some models, time emerges from something more primitive, interactions of quantum information, networks of entanglement, or a timeless landscape where moments crystallize like ripples forming on the surface of still water. In that view, there was no before because before had not yet been invented by the universe. Imagine a reality where time grows like frost, spreading across a window, forming edges, branches, and patterns from something that had no shape. Or imagine a universe where time is more like temperature, something that appears only when countless microscopic elements work together. Without the right conditions, time might not flow at all, it might simply be absent. Still, other ideas describe the universe as a quantum fluctuation, a spontaneous event arising from a deeper invisible framework. Not deliberate creation, not a planned event, but the kind of natural process that takes place when quantum rules govern everything. In that scenario, the universe did not require a cause. It simply happened as particles constantly do at the smallest scales. These proposals may sound abstract, but scientists hunt tirelessly for evidence. They examine the cosmic microwave background, the oldest light in the universe, searching for irregularities in its temperature that might point to a contracting phase or a bounce. They measure gravitational waves for hints of primordial echoes. They map the distribution of galaxies looking for strange symmetries or distortions that could reflect conditions predating the universe's earliest known moments. Every ripple, every faint vibration, every pattern in the sky becomes a potential fossil of cosmic ancestry. And yet, even with all these efforts, the truth remains elusive. Perhaps it always will. There's a softness in accepting that uncertainty, a kind of peace. The idea that the universe may not give us a clean beginning, a definite first step, is strangely comforting. It invites us to breathe a little more deeply and recognize that some mysteries are not meant to be solved all at once. Our desire to imagine a beginning is deeply human. We crave origin stories. They ground us in time, give structure to our place in the world, and help us feel connected to a larger narrative. But the cosmos does not owe us simplicity. It doesn't promise a single answer or a clean line separating before and after. Instead, it leaves hints, questions, and possibilities, open doors rather than closed rooms. As you lie here tonight, consider that the universe may be far older than the story we typically tell. It might have cycled through multiple lives, or it might have emerged from a realm where time behaves nothing like the steady rhythm we measure on clocks. It might even be part of a larger structure, a foam of universes, each bubbling into existence with its own version of beginnings. What came before time began, a contraction, a bounce, a timeless state, something beyond our language we may never know. But there is beauty in the wondering. Allow that mystery to settle beside you like a soft blanket. Let your mind drift between questions and possibilities without needing to hold any of them tightly. As the universe expands outward in silence, your thoughts can expand inward with the same gentle curiosity. Some questions are too large for answers. Some beginnings are too old for memory. Some stories start long before the first page is written, and tonight we rest in that stillness. When you step outside at night and look upward, it's easy to imagine space as a vast flat canvas, an endless black sheet stretching out in all directions. But the true shape of space may be far more subtle, far more intricate, and far more mysterious than our intuition suggests. Our senses evolved to navigate forests, rivers, mountains, not the grand structure of the cosmos. So when we try to imagine the shape of the universe itself, we feel like children tracing the outline of a building by touching only one brick. The universe might be infinite, it might be finite but unbounded. It might curve gently like a sphere, or bend subtly like a saddle, or loop back on itself in a way almost impossible to picture. And the most challenging part, even if we lived for billions of years, even if we crossed galaxies, even if we built perfect instruments, we might never be able to measure the universe's true shape, infinite space. In one possibility, space extends forever. No edges, no boundaries, no walls at the far edge of existence. Just an endless, seamless expanse where galaxies continue forever, like light scattered across a boundless ocean. In such a universe, every place is like every other place in the grand scheme, no center, no edges, no outer wall marking where everything stops. But infinity is hard for the human mind. We can count steps, we can imagine long roads, we can scale mountains. But forever is not the scale. It's a horizon that retreats every time we approach it. A finite but edgeless cosmos. The universe might also be finite yet without a boundary. Like the surface of a sphere, you can walk in any direction without ever encountering an edge, yet the surface has a measurable area, a finite world with no end. Extend that idea to 3 dimensions and you get a strange possibility. You could travel in a straight line through space, never turning, never stopping, and eventually return to the exact point where you began. Not like orbiting a planet, but by moving in a straight line through the fabric of space itself. Imagine walking across a foggy spherical world. There are no signs, no cliffs, no walls, just soft mist and an endless horizon. You keep walking, and after a very long time, years, decades, you find yourself back where you started. Not because you turned around, but because space itself curves. In such a universe, if you look far enough in the right direction, you could theoretically see the back of your own head, like looping around the cosmos returning to you from behind, a cosmic hall of mirrors, quiet and immense. Looped reality. Some models describe space as a complex shape with multiple loops and twists, like a three-dimensional version of a Möbius strip or a donut with multiple tunnels. These shapes, called topologies, let space be both finite and strange. You could exit on one side of the universe and re-enter on another, like stepping through a doorway you didn't know was there. Reality might be stitched together in ways we can't visualize. Space might connect to itself. Directions might secretly fold. Distances might hide shortcuts or long cuts. The true shape of the cosmos might be far richer than anything we imagine while lying in bed staring at the ceiling. The difficulty of measuring the whole. Here's the challenge. We only see a tiny patch of reality, the observable universe limited by how far light has traveled since the beginning of time. It's like trying to map the shape of the entire Earth while standing in a fog-shrouded valley with only a few hills visible. You could walk north, south, east, west, but the fog hides everything beyond a small circle. From your limited view, the world might look flat. Even if it curves, the curve would be too subtle to detect. The universe may curve so gently over distances so enormous that even billions of light years of observation aren't enough to reveal it. Our tools are powerful, but the cosmic fog is vast. Scientists study the shapes of galaxy patterns, the geometry of ancient light, and the way triangles behave on cosmic scales. If space is curved, a triangle drawn between three distant galaxies won't add up to 180 degrees. If space loops, patterns might repeat in the cosmic microwave background like wallpaper tiles. But so far the clues remain faint, ambiguous, whispered rather than clear. It's possible that the universe is curved, looped, finite, strange, yet the curvature is so mild that our entire observable region looks flat. In that case, we are like ants on a sphere so large that its surface feels like a flat plane beneath our tiny feet. Wandering through a boundless domain. As you listen, imagine yourself walking through that foggy world again. No edges, no cliffs, just soft ground and a horizon that never ends. Every step feels the same, yet the world gently curves beneath your feet, guiding you in a circle you'll never notice. That is what space might be doing around you right now, subtly shaping the paths of galaxies, bending the arc of starlight, curving the geometry of existence, in a way too broad for any one human life to grasp. Whether infinite or finite, curved or flat, looped or simple, the universe holds a kind of serenity in its ambiguity. You don't need to solve its geometry to appreciate its immensity. You don't need to know its borders to feel wonder at its scale. As you lie here wrapped in quiet, you're drifting through a cosmos without edges, an ocean of space that stretches beyond imagination, inviting you to wander in thought, even as your body rests. In a universe without boundaries, the mind is free to explore without fear of reaching an end. And tonight you can drift through that boundless domain at your own pace. No rush, no expectations, just curiosity and calm. When we look around at the walls of our room, the floor beneath our feet, the ceiling above it, feels obvious that space has three dimensions: left, right, forward, back, up, down. These directions are so familiar that we almost forget they are assumptions built into our senses, carved into our intuition by a lifetime of moving through forests, doorways, and streets. But the universe may not be limited to those three directions. Space may be hiding more. Extra dimensions sound like science fiction, but they arise naturally in some of the most powerful theories we use to describe the cosmos. These dimensions wouldn't be large and roomy like the ones we inhabit. They could be tiny, curled-up directions woven into the very fabric of reality, so small that even particles cannot easily move through them, so subtle that our instruments cannot detect them, so hidden that our minds cannot picture them without stretching imagination to its edge. One way to understand this is to think of a sheet of paper. From far away it looks two-dimensional, flat, thin and simple, but if you zoom in closely enough you'll find thickness. You'll find fibers, bumps, ridges. You might even find layers. Dimensions that were invisible from a distance suddenly reveal themselves when you look with greater precision. Now imagine space itself is like that paper. To us large beings made of atoms, it seems three-dimensional. But if you were small enough, if you were the size of a quantum particle, you might discover that space has extra directions folded tightly into microscopic loops. Physicists often compare these hidden directions to tiny circles at every point in space. The circles are so minuscule that they are impossible to move through. Impossible to see, impossible to detect directly, but they influence the behavior of particles, the formation of forces, and the structure of everything around us. Imagine walking along a long, straight garden hose. From far away it looks like a one-dimensional line you can walk forward or backward. But if you're tiny, say an ant, you also have another option. You can walk around the circumference of the hose, a whole extra direction that the human eye completely misses. Our universe may be like that garden hose. At human scale, it feels like 3 dimensions. But deep down, woven into the fabric of reality, there could be hidden loops, folded layers, curled directions, dimensions just out of reach. Some theories propose 1 extra dimension. Others suggest 2 or 6 or even more, each curled up in intricate shapes known as Calabi-Yau manifolds, mathematical forms so complex and delicate that they defy ordinary visualization. These shapes could determine everything about our reality: why electrons have their specific mass, why fundamental forces have their strength, why atoms hold together the way they do. In other words, the appearance of our world might be shaped by dimensions we never see. This idea brings a quiet kind of humility. We tend to believe that our senses show us the full extent of existence. Touch, sight, sound, they define our world, but our senses evolved for survival, not comprehension. They reveal enough to keep us alive, not enough to reveal the deepest architecture of the cosmos. There might be entire layers of reality we simply never evolved to notice. As you lie here tonight, imagine that beneath the room, around you, beneath the mattress, beneath the air, beneath even the atoms, there are hidden directions folded like the pleats of an origami crane. The folds are too small to move through, too subtle to disturb, but they are there, shaping the rules of everything you see. Imagine the entire universe as a sheet of paper being gently folded. From a distance it looks flat, but in the folds hidden valleys and ridges lie possibilities our eyes cannot reach. Or imagine each point in space as containing a tiny loop, smaller than the smallest proton, curled tightly like a secret passageway sealed shut. Everything you've ever seen exists on the broad paths of our 3-dimensional world, never dipping into those secret directions. They are hidden not by walls but by scale, and this is perhaps the most beautiful part. Even if these dimensions are forever beyond our reach, they whisper to us through the patterns of particles, through the symmetries of physics, through the behavior of the universe itself. Their presence may be silent, but their influence is everywhere. The universe, it seems, may be deeper than it appears, richer, more layered, and we with our limited perception glimpse only the outer surface. But that's all right. There's serenity in knowing that the cosmos still holds mysteries tucked into its smallest corners, that not everything needs to be seen to be real, that entire dimensions may exist just out of reach, like rooms behind a wall you can touch but never enter, or songs whose notes you feel but cannot hear. As you relax into the quiet of the night, let your thoughts drift into those hidden directions, not to solve them, not to grasp them, but to let the idea that reality is larger than perception bring you a gentle calm. Space may be folded, reality may be layered, and you resting here are part of a universe far deeper than the senses reveal. If you stretch out your hand in front of you right now, it will pass easily through what seems like empty air. And if you travelled far beyond the Earth, past the Moon, past the quiet dark between planets, you would find even more emptiness, vast stretches of space, containing almost nothing at all. Or so it appears. But emptiness in the universe is an illusion, a comforting one, a simple one, and a deeply misleading one. Because space, true deep intergalactic space, is not a hollow void. It is not a blank canvas waiting to be filled. It is a physical entity, a restless medium, a structure humming with unseen activity. In the last century, science has peeled back the silence and discovered that what we call nothing is actually one of the most crowded places imaginable, space as a woven fabric. Physicists sometimes describe space as a fabric, and although the metaphor is imperfect, it captures something essential. Just as cloth is made of interlaced threads, reality itself may be woven from tiny fundamental units, bits of information, quantum connections, or geometric relations so small that even our finest microscopes cannot glimpse them. Imagine lying beneath a huge, heavy blanket. When you look closely, the fabric resolves into individual threads, crisscrossing and looping over one another. But from a distance, the blanket looks smooth and continuous. Space is like that. We experience it as a smooth, continuous volume, but at the tinier scale it may be made of discrete pieces, little grains of space-time, tiny pixels of reality too small for any probe to detect. Some theories imagine these threads as quantum nodes connected by links like a shimmering network that stretches across the universe. In this picture, distance, directions, and even the geometry of space emerge from the pattern of connections. Space is not the stage where particles move. It is the result of the particles' relationships, a cosmic tapestry woven out of pure interaction. A shimmering ocean beneath reality. Another way to imagine space is as an ocean calm on the surface, turbulent below. At everyday scale, space seems smooth and empty. But if you could shrink yourself down many orders of magnitude, the tranquility would vanish. You would find yourself tossed in a storm of activity particles popping into existence, colliding, annihilating, appearing again. This is the quantum vacuum, one of the strangest discoveries in physics. Even when you remove all matter, even when you lower temperature to absolute zero, even when you try to eliminate all energy, the vacuum still vibrates. It seethes with fluctuations. It roils with temporary particles, virtual fields, and bursts of energy that blink in and out of being. Empty space is not empty. It is a restless sea. These fluctuations are not theoretical decorations, they produce real effects. They shift the energy levels of atoms. They tug on particles. They subtly alter the forces around them. In some regions of the universe, they may even drive entire phases of cosmic evolution, like inflation or dark energy. The vacuum is the quiet heartbeat of the cosmos, invisible, continuous, always humming. Emergent space. When geometry is not fundamental, perhaps the most profound idea of all is that space itself might not be fundamental. It might be emergent, like temperature or pressure properties that appear only when trillions of molecules behave in concert. In this view, space is not the container for reality. It is the product of reality. Imagine a snowflake. From a distance, it looks like a sweeping geometric pattern, 6 arms, intricate symmetry. But zoom in far enough and the snowflake dissolves into individual molecules arranged by simple rules. The large-scale beauty is not fundamental, it is emergent. Space may be the same. The geometry we experience, straight lines, distances, angles, might arise from deeper relationships, quantum entanglement, or interactions encoded in ways we have not yet discovered. Some scientists imagine the universe as a vast web of entangled information. When regions of this web share strong connections, they appear close in space. When the connections weaken, those regions appear distant. Space is the map of those connections, nothing more, nothing less. In that sense, space is a story told by the universe about how its tiniest parts relate to each other. The mystery of nothingness. As strange as all of this sounds, perhaps the most comforting truth is that nothingness is full of potential. It is not a cold or barren concept. It is dynamic, fertile, and alive with subtle energy. The vacuum is the canvas upon which galaxies form. It is the reservoir from which fluctuations seed stars and structure. It is the hum beneath every atom, the whisper beneath every particle. Think of space as a field of possibility, a quiet, shimmering presence supporting everything we see. When you lie in the dark listening to the stillness of your room, that same stillness exists between stars, between galaxies, between every corner of the cosmos. But beneath that stillness is motion. Beneath silence is vibration. Beneath emptiness is structure. The universe is never truly quiet. As you rest tonight, imagine that the space around you is gently shimmering, not in a way your eyes can see, but in a deeper, subtler way. Reality hums softly, patiently, weaving itself moment to moment from networks of quantum relations, and you are part of that fabric, a pattern within it, a ripple in the ocean of existence. Space is not just where you live, it is what you are made of, what everything is made of. A mystery we touch every second without ever feeling its depth. Let that mystery wrap around you like a warm blanket. Let it soothe you. Let it remind you how much remains unseen and how beautiful that hidden world must be. We like to think of time as something steady, an invisible river flowing at the same pace everywhere, carrying all things along together. Our clocks tick in unison, our days rise and fall in familiar patterns, and the past always feels like it sits behind us in a neat, orderly line. But in the universe, time is not so obedient. It stretches, bends, ripples, slows, and speeds up depending on where you are and what surrounds you. There is no single universal moment shared across the cosmos, no cosmic clock synchronizing all things. Time is local, personal, a patchwork stitched together by gravity and motion. Time in a gravitational well. Einstein's theory of relativity tells us that gravity is not just a force, it's a warping of space and time. Massive objects like planets and stars create depressions in the fabric of space-time. Inside these depressions, these gravitational wells, time runs more slowly. We don't notice it in daily life, but the effect is real and measurable. If you place two identical clocks, one at sea level and one on top of a mountain, the clock at sea level runs slightly slower. The difference is tiny, but it accumulates. In fact, the GPS satellites orbiting above Earth tick faster than clocks on the ground because they're farther from our planet's gravitational pull. Engineers must correct this difference constantly. Without compensating for time dilation, your phone's navigation would drift by kilometers every day. Even your head ages faster than your feet simply because it is a little farther from Earth's center. You may not feel it, but your body spans a gradient of time. Time slows near enormous mass. Now imagine standing near something far more massive than Earth. Near a neutron star, time crawls. Near a black hole, it nearly stops. If you hovered safely outside the event horizon of a black hole, your seconds would stretch so dramatically that an hour for you might equal thousands of years for the outside universe. To distant observers, you would seem frozen, suspended in slow motion. To you, everything else would rush forward, stars, aging galaxies, drifting, civilizations rising and falling. In the deepest gravitational wells, time becomes viscous, thick, reluctant to move. Time speeds up in open space travel, far into intergalactic space, far from stars, planets, or gravitational pressure, and time flows more freely. Like water running downhill, it moves a little faster there. A second in the emptiest void passes more quickly than a second on Earth's surface. It is a small difference, but it is real. If you could drift through the cosmic emptiness between galaxy clusters, you would age just a little faster than someone who stayed at home, even without moving at high speed. The universe has no shared present. All of this creates a strange and beautiful consequence. There is no universal now. Your present moment is not the same as the present moment on a star 10 billion light-years away. Even here on Earth, no two clocks agree perfectly. Time is stitched together from countless local experiences like a quilt whose squares never quite align. When you look at the night sky, you aren't seeing a single shared moment. Each star shows you a different slice of time. A galaxy might appear as it was 30 million years ago. A nearby star just 8 years in the past. A distant quasar, a glimpse into an era before Earth even formed. The universe is a mosaic of memories, each one delivered to us on a thread of light. Time in extreme regions. Now imagine what time feels like near the universe's strangest places. Near a black hole, moments stretch into eternity. Near a neutron star, the gravity squeezes not only matter, but time itself. Inside the early universe, moments passed faster than we can comprehend, fractions of seconds, birthing entire epochs of structure. In the cold void, time floats freely, smooth and unhindered. At the speed of light, time stops completely. Photons experience no passage of time at all. A beam of light leaving a distant galaxy billions of years ago experiences its entire journey from its birth to the moment it touches your eye as a single instant. For you, those billions of years were a grand voyage. For the photon, they were no time at all, time as a patchwork. All of this leads to a quiet realization. Time is not a river. It is a landscape, uneven, textured, and shaped by what lies within it. Your time, Earth's time, the sun's time, a black hole's time, a drifting photon's timelessness. All coexist, layered over one another like the strokes of a painting. As you rest tonight, let that thought soften the edges of your mind. Your heartbeat, your breath, the seconds on the clock, they belong to your little corner of space-time. Someone on a mountain is aging faster. Someone in orbit is aging faster still. Someone deep in a gravity well ages slower. A photon ages not at all. And somewhere across the universe, on a distant planet circling a distant star, another being, if such beings exist, experiences their own version of now their own patch of the cosmic quilt. There is no single rhythm that defines reality, only local rhythms gently overlapping. So breathe at your own pace, rest in your own time, Your moment is yours alone, one thread in the vast shimmering tapestry of space-time. When cosmologists speak of the early universe, their voices often drift into metaphors because what happened in those first fractions of a second escapes ordinary language. One idea called inflation suggests that space didn't simply expand, it ballooned outward with unimaginable speed, faster than light, faster than thought. In the blink of an eye, a tiny patch of primordial energy stretched to cosmic size. But inflation doesn't just describe our universe's beginning, it hints at something even stranger, the possibility that our universe is only one bubble in an ever-growing cosmic sea. The birth of bubbles. In many inflation models, the expansion never truly ends. Even after our universe cooled and slowed, other regions continued inflating endlessly, relentlessly, like pockets of rising dough. Every so often, the inflationary field relaxes in one region, allowing a bubble universe to form, cool, and evolve. But around those bubbles, the larger space keeps stretching, pulling them apart faster than they can ever meet. Imagine a pot of boiling water. Each bubble forms from the same liquid, yet each one is its own world, separate, sealed, expanding for a moment before drifting away. Now replace the water with space-time itself. Replace steam with quantum fields. Replace the kitchen with the infinite. That is the multiverse envisioned by eternal inflation. A vast, unstoppable froth of universes, each a bubble, each isolated, each growing its own galaxies, stars, and histories. Cosmic bubbles with different rules. Here's where the idea becomes even more profound. Each bubble universe may have slightly different physical laws. Perhaps gravity is stronger in one bubble. Perhaps atoms behave differently in another. Perhaps some bubbles never form stars at all. Perhaps others ignite stars more easily, burn them faster, or give rise to exotic structures beyond our imagination. Our universe is one particular bubble where the conditions happen to stabilize in a way that allows galaxies, planets, life, and consciousness to arise. A lucky pocket, a region where the cosmic dice landed gently enough for order to take shape, never meeting the neighbors. Because inflation continues outside the bubbles, space stretches so quickly that no two universes can ever touch. Their edges move away from each other faster than any signal can travel. Even if two bubbles began side by side, the swelling gap between them would outpace light itself. Each cosmos becomes an island surrounded not by water, but by an ever-expanding gulf of unobservable space. We will never see another bubble, not because they are small, but because the space between us grows too fast. The multiverse, if it exists, is a vast collection of worlds forever hidden from one another, chapters in the same book whose pages cannot be turned. The emotional weight of the multiverse. If this sounds overwhelming, that's natural. The idea raises questions that touch both science and the heart. What does it mean to be part of something so immense that we can never see its full extent? What does it mean to live inside one universe among countless others, one bubble suspended in a cosmic ocean? There is a quiet humility in imagining this, a sense of perspective, a feeling that our reality, vast as it seems, might be just one note in a much larger symphony. But there is comfort too. If there are countless universes, each with its own rules and history, then our existence becomes not an improbable miracle, but an expected outcome somewhere in the vastness. The multiverse gives space for all possibilities, dark universes, bright universes, simple ones, chaotic ones, living ones, silent ones. We live in one where stars burn long enough to foster life, where atoms hold together, where quiet nights like this are possible. That alone is extraordinary. A meditative drift through the infinite. As you lie here breathing softly, imagine the universe around you, a bubble filled with galaxies, stars, planets, nebulae, dark matter, and the slow drift of cosmic time. Now imagine beyond this bubble another one forming, and another, each expanding, each isolated, each carrying its own version of reality. Picture these bubbles floating in an ever-stretching medium, a boundless expanse where inflation continues, eternally birthing new universes as effortlessly as waves rolling across the sea. We cannot see them, we cannot visit them, but their existence would mean that reality is larger than any story we have ever told. You are part of one bubble, one cosmic droplet carrying its own unique blend of laws, constants, and possibilities. You could have been born in a universe where atoms never form, a universe where time behaves differently, a universe with no stars, no light, no chemistry, but instead you're here in a bubble that nurtures complexity and warmth, a universe where someone can lie in bed in the quiet of the night and wonder. The soft mystery of the many. If the multiverse is real, then we are not alone, not in the sense of alien life, but in the sense of cosmic kinship. Our universe sits alongside countless others, each unfolding its own silent, unreachable story. And we inside this small glowing bubble get to feel curiosity. We get to imagine. We get to breathe and drift and dream. Let that thought settle gently. A universe among universes, a bubble among bubbles, a story within a story. You don't need to grasp the entire structure to feel awe. You only need to know that reality is far larger, deeper, and more mysterious than the light that reaches your eyes. And in that immensity, you're perfectly placed in a bubble that knows how to bloom stars, warm planets, and cradle consciousness. Rest in that wonder, drift with it, let it carry you gently into the next quiet chapter of the night. Across the observable universe, astronomers map a breathtaking lattice of matter, clusters of galaxies huddled together, filaments stretching like glowing threads, and immense voids where almost nothing resides. This pattern known as the cosmic web is the largest visible structure we have ever uncovered, and yet it may only be the faint outline of something far grander. Our cosmic horizon limits what we can see. Light has travelled for only 13.8 billion years since the Big Bang, which means anything beyond that distance remains invisible. Not because it isn't there, but because its light has not and will never reach us. And still something calls from beyond. Hints, whispers, gravitational footprints pressed into the part of the cosmos we can observe. The shadow of colossal structures. Astronomers have discovered superclusters so large they stretch across unimaginable distances. The Sloan Great Wall, the Hercules Corona Borealis Great Wall, and the Laniakea supercluster that holds our own Milky Way. These formations span billions of light years, defying simple expectations of randomness. But even these giants might be dwarfed by structures lurking beyond our reach. We catch only clues, slight drifts in the motion of galaxy clusters, curious alignments in the cosmic microwave background, temperature patterns that seem to tug in a consistent direction. Some researchers call this the dark flow, a peculiar motion of galaxies moving as if pulled by a massive concentration of matter outside our visible universe. Whether this flow is real or an illusion remains debated, but its implications, if confirmed, are staggering. Imagine a cosmic continent so vast that it influences the motion of galaxies separated by hundreds of millions of light years. Imagine gravitational mountains rising in regions we can never visit. Imagine cosmic basins so deep that their pull bends the paths of clusters like rivers curving around unseen valleys. Structures, too large to comprehend. Inside our window of visibility, we see beauty galaxies forming long strands like glowing spider silk stretched across the dark. But what lies beyond that window may be orders of magnitude. Larger structures that stretch across regions no light from our side can reach. Formed in the early universe long before any identifiable cluster, they exist in pure darkness made of matter we cannot detect, leave only subtle fingerprints on what we can observe. The observable web may be just the center of a much larger tapestry. The cosmic patterns we see might continue outward like ripples or break into unexpected forms, knots, arcs, sheets, or vast river-like flows of dark matter. Edges of data, edges of imagination. Astronomers often describe their work as looking for shapes in fog. We see only the fogged-in center of the universe, a bubble of light surrounded by darkness. Beyond the boundary, the universe continues, but invisibly its structures casting long gravitational shadows we detect only faintly. Consider a distant galaxy's motion appears slightly off course. The cosmic microwave background shows a warm or cool patch larger than expected. A region of the sky displays a puzzling alignment of quasi-polarization. Each of these might be coincidence or the tip of a hidden continent of cosmic structure pressing gently against our horizon. Like sailors approaching the edge of old maps, we infer what lies beyond from changes in the waves, beneath us from the shape of the wind on our sails, the atmosphere of the unseen. Imagine drifting through intergalactic space. No stars, no planets, only the faintest glow of galaxies far away. But gravity is everywhere, a silent pressure, a pull without a source we can see. You might feel the presence of something massive the way hikers sense a mountain obscured by fog, not from sight but from the way paths bend, from the way the air shifts. In the cosmic sense, we also feel such mountains, unseen gravitational giants that shape the motions of galaxies, leaving an invisible handprint on the universe's architecture. These titanic structures may never send us light, but they leave ripples, curvatures, subtle distortions that whisper of a cosmos far larger and far stranger than our telescopes can capture. A meditation on hidden worlds. As you relax into the quiet, let yourself imagine the vastness beyond our vision. Entire supercontinents of galaxies stretching so far that even light gives up. Dark realms where matter clusters in forms we have no name for. Unseen skeletons of the universe pressing gently against our cosmic bubble. Our universe is not empty. It is full of structure, seen and unseen, reachable and unreachable. And at this moment, somewhere out there in the vast dark galaxies glide along gravitational highways shaped by titans we will never witness. Let that thought settle softly, that the universe we see is only a small room in a far larger mansion, and beyond the walls lie halls and corridors whose existence we know only through shadows and gently bending light. You're looking through a narrow window into a limitless architecture, and the deeper we look, the more we realize we're standing at the edge of something vast, something waiting quietly just beyond the glow of our telescopes. When we look up at the night sky, it is natural to imagine the universe as a vast room, perhaps incomprehensibly large, but still a room with some kind of boundary far, far away. A wall, a border, a final frontier where everything simply stops. But in physics, the idea of an edge of the universe becomes slippery, almost meaningless, because edges imply something beyond them, a place to stand, a direction to point, a surface to cross. And our universe doesn't seem to work that way. Finite yet without edges. One possibility consistent with everything we've measured so far is that the universe might be finite in size but have no boundary. This sounds impossible until we remember that we already know objects with exactly this property. Take the surface of a sphere. If you walk across Earth in a straight line, you never fall off any edge. You simply return to where you began. The surface is finite but edgeless, a continuous loop with no borders. Now take that idea and lift it into more dimensions. Imagine space not as a flat expanse, but as a three-dimensional analogue of a sphere's surface. In such a universe, you could travel infinitely far without reaching a boundary. You would never find a wall or a cosmic cliff. You might even return to your starting point after circling the cosmos, though expansion may make such a journey impossible in practice. In this model, the universe feels infinite from the inside, even though it is technically finite. Every direction is open. Every path loops subtly in ways too large to sense. Why edge is a misleading word. When people ask whether the universe has an edge, they usually imagine something like the horizon at sea, a limit you could approach and cross. But cosmic horizons are not physical barriers. They are regions from which light simply hasn't reached us yet. The edge of the observable universe is not the edge of everything. It is simply the furthest distance light has had time to travel since the Big Bang. And that horizon grows with time. Every second more of the universe becomes visible. There is no wall, only a moving frontier of light. The true universe could extend far beyond what we see. It might be infinite, or it might curve back on itself. Both possibilities remain open. Expanding the analogy. To picture a finite, edgeless universe. Imagine this. You're an ant walking along a balloon. No matter which way you travel, you will never find a border. You won't fall off. The balloon is finite, yet it has no edge. It contains a smooth, closed surface without a boundary. Now imagine that instead of the balloon's surface, you live inside its three-dimensional volume. That's the key. The balloon's interior corresponds to a hypersphere, a volume that loops back on itself in a higher dimension. You wouldn't feel the curvature. You wouldn't sense the loop. It would look and feel just like infinite space. Only careful measurements, the shape of cosmic microwave background patterns, the distribution of galaxies would reveal the curvature, and even then only subtly. So far, all measurements say one thing. If the universe curves back on itself, the radius is so large that the curvature is indistinguishable from flatness. If space-looped, would we see repeats? In theory, a closed universe might create ghostly repetitions patterns in the cosmic microwave background, where light has circled the cosmos multiple times. Scientists search for these match circles in the sky. So far, none have been found, but the data is not perfect. The idea remains alive, waiting quietly for better instruments. Imagine seeing a galaxy billions of light years away. and realizing it is our own galaxy seen from a different direction, its light taking a longer path around the cosmic loop. Like looking into a hall of mirrors but stretched across billions of years. We haven't found such echoes, but the possibility lingers a reminder that space might be stranger than our senses allow. What if the universe does have an edge? Another possibility is that the universe is infinite, it just goes on forever. In that case, no boundary exists. No wall, no outside, only more space, more galaxies, more silence. An edge in this sense makes no more sense than asking, what is north of the North Pole? The coordinates simply end. The concept breaks down. If the universe is infinite, then the idea of an edge dissolves entirely. There is no ending point, no border separating something from nothing. Space simply is stretching endlessly in all directions with no need for a container. A soft, soothing meditation on boundaries. As you relax deeper into the quiet, imagine walking across a vast plain. The horizon remains the same distance away no matter how far you travel. There is no cliff, no boundary, just the feeling of openness around you. Now, lift that image into the stars. The universe too offers no sign of a stopping point, only the gentle curvature of possibility. Whether space loops in on itself or extends outward without end, you are held within a reality that has no walls. You are not living inside a box. You are floating in a boundless expanse where edge is a human longing, not a cosmic truth. Let that soothe you. Let it unspool the mind's tight knots. Because in a universe without edges, there is always space to breathe space, to drift space, to wander space, to rest. When we hear that the universe is expanding, the mind naturally leaps to a picture, galaxies racing outward into some kind of black void like shrapnel, scattered from an explosion pushing into an empty room. It feels intuitive, but it isn't what the science says. The universe is not expanding into anything. There is no external space, no cosmic chamber surrounding us, no silent void waiting to be filled. Space is expanding within itself, the way a pattern on a balloon grows as the balloon inflates not outward into the surrounding air, but outward from every point stretching distances everywhere at once. The balloon analogy and what we miss. Imagine tiny dots on the surface of a balloon. As the balloon expands, every dot moves away from every other dot. None of the dots get closer to a center. The surface itself stretches even though the material is infinitesimally thin. From the perspective of a creature living on that surface, there is no outside. There is only the stretching world beneath their feet. Now expand that idea. Replace the balloon's two-dimensional surface with a full three-dimensional volume. Replace dots with galaxies. Replace the rubber with space-time. That's us. We live on and within that inflating fabric. But here is where human intuition breaks on the balloon. We can imagine the air outside the room containing it. Our universe has no such container. The outside of space is not a place. It is not a location we can point toward or travel into or even describe meaningfully. Not because it's too far, but because it does not exist. If there is no outside, what is expanding expansion does not require emptiness beyond it. It only requires change in distance between points inside the universe. Imagine a quiet night with no wind, no clouds, no sound. Now imagine every tree, every hill, every star in the sky gently sliding farther apart, not because they are moving, but because the fabric beneath them is stretching. Expansion doesn't push galaxies through space, it creates the space between them. Every second more space appears between distant galaxies like new threads, weaving themselves into a tapestry that keeps growing even as you look at it. But what is it expanding into? This question is universal. Children ask it, scientists ask it. The human brain almost requires an outside. We evolved to understand rooms, mountains, oceans, environments with shapes, boundaries, walls. Our imagination struggles with something that has no outside at all. When cosmologists answer, it expands into nothing, the word nothing misleads us. We imagine a black void, emptiness we could step into. But in physics, nothing doesn't mean emptiness. It means the absence of space itself, not a vacuum, not a darkness, not a room unlit, just nothing. The universe isn't inflating into darkness, it is inflating instead of darkness. Trying to picture the impossible. Our minds rebel against this. We try to visualize a boundary, a shell, a bubble floating in something. but every picture collapses into contradiction. We instinctively place the universe somewhere a habit of thought, built from a lifetime of seeing objects occupy space. But the universe isn't an object in space, it is the space. Every location that exists is inside it. Every direction, every angle, every dimension. If something existed outside, it would simply be part of the universe instead. So when we imagine expansion, the challenge is not to picture galaxies traveling outward into emptiness, but to imagine the distances themselves blooming like petals unfurling in a flower too large for any garden. What if there were an outside? Some speculative theories propose higher dimensional realms in which our universe might be embedded like a soap bubble, floating in a foam of other bubbles, each one a distinct cosmos. But even these theories place no space outside the multiverse. They simply redefine the notion of outside into something stranger than language can carry. If such a realm exists, it may not contain matter, energy, or geometry as we know them. It might not have time. It might not have distance. It might not even have place. Trying to imagine it feels like trying to smell a color or hold a sunset. We're using tools built for Earth to grasp structures built for the cosmos. An emotional drift into wonder. As you breathe slowly, imagine standing on a limitless plain. No edges, no walls, no frontier, yet every moment the plain expands beneath your feet, not pushing you, not carrying you, just gently increasing the distances between distant hills you will never see. Now imagine that plain filled with galaxies, each one drifting apart not by force, but by the quiet stretching of the fabric beneath them. The expansion is not violent, it is not explosive, it is not loud, it is more like the slow rise of morning light, or the steady unfolding of a tide, or the deepening of night. A soft cosmic exhale. You are floating inside that breath, a tiny point in a universe that expands not outward but everywhere, not into space, but as space not against anything but through the gentle growth of itself. Let that thought soften your mind. Let it remind you how vast reality truly is, and how profoundly mysterious it remains, even after all the measurements, all the equations, all the light we have captured from across the ages. The universe is expanding, and you are here inside that growing room of stars listening to the quiet rhythm of existence stretching gently around you. When we look out into the universe not with our eyes but with instruments sensitive to the faint glow left from the Big Bang, we find something astonishing. The cosmos on the largest scales is smooth, not featureless, not empty, but remarkably uniform. The same temperature, the same density, the same soft glow across distances so vast that light itself has not had time to travel between them. This harmony shouldn't exist. Distant regions of the sky are far too far apart to have communicated in the early universe. They could never have exchanged heat or light or information, and yet they look almost identical as if they were once in perfect agreement. This mystery is known as the horizon problem, and the solution points to one of the most beautiful ideas in cosmology: inflation. The universe began much smoother than it should have. Under ordinary expansion, the early universe would have been like a patchwork quilt, different regions forming with different temperatures and conditions. There hasn't been enough time since the Big Bang for these regions to settle into equilibrium. Yet the cosmic microwave background, the afterglow of creation, shows differences so tiny, about 1 part in 100,000 luns, that the entire sky looks like a softly painted watercolor wash. It is like standing on opposite sides of Earth lighting 2 bonfires and discovering the flames are dancing at exactly the same height, temperature and rhythm despite no wind, no contact, no shared spark. Something must have connected everything in the beginning. Inflation, the great smoothing. Inflation proposes that before the universe expanded slowly, it expanded absurdly fast, faster than any light signal could travel. In a fraction of a fraction of a fraction of a second, the universe grew from subatomic size to something macroscopic. But before that rapid expansion, when the universe was unimaginably tiny, every region could communicate. They were close enough to exchange heat, close enough to share information, close enough to settle into the same temperature. Then inflation stretched that uniform tiny region into the vast cosmos we see today. All the smoothness we observe, all the harmony in the cosmic microwave background is the imprint of a once connected universe inflated beyond recognition. It is as if you took a grain of sand perfectly polished and smooth and blew it up to the size of a galaxy, or hundreds of galaxies, yet every feature of its surface retained the same exquisitely uniform texture. tiny fluctuations become cosmic architecture. Of course, the universe is not perfectly smooth. It contains tiny ripples, almost imperceptible variations in density and temperature. These are visible as faint blots and speckles in the cosmic microwave background map, and those tiny ripples stretched by inflation became the seeds of everything: galaxies, stars, planets, you. The entire cosmic web originates from little quantum tremors frozen into place by inflation. In this sense, every cluster, every spiral galaxy, every starry night is the magnified echo of a quantum whisper, a universe that agreed with itself. Without inflation, distant galaxies would be strangers, unconnected, uncoordinated, chaotic. But with inflation, they are siblings born from the same tiny region carrying the same early memory. There is beauty in that idea, that the universe began as something small and unified, and that unity echoes across billions of light years in the form of harmony. The cosmos is smooth because it remembers being one, a gentle meditation on harmony across the void. Imagine standing in a calm desert at dawn, the air cool, the sand silent, the horizon washed in soft light. Everything feels balanced, quiet, evenly toned. Now imagine that same softness spread across the entire universe, a gentle equality of temperature and structure stretched over distances so vast they defy comprehension. That is the cosmic microwave background, a glowing memory of the universe's earliest breath, a portrait of equilibrium painted across the sky. And in that uniformity we find reassurance. The universe is not random chaos. It carries echoes of a shared beginning, a moment when everything was close, connected, intimate. As you lie here tonight, let that thought settle in you, that billions of light years away in every direction, the universe holds the same quiet temperature, the same faint glow, the same memory of its earliest, softest state. A harmony born from a moment of unimaginable stillness, a smoothness that binds the cosmos together, a reminder that everything, even galaxies separated by cosmic oceans, once touched. Let that sense of connection soothe you. Let it remind you that the universe at its deepest level is shaped by quiet symmetry, by shared origin, by the gentlest ripples of creation. You're part of that cosmic smoothness, a small ripple in a vast harmonious whole. If the Big Bang was the beginning of everything, space-time, matter, energy, then it seems impossible that anything older could leave a mark. How can an event that happened before time began leave fingerprints on the universe that came after? And yet some cosmologists suspect the universe may carry scars from an era that preceded the Big Bang, barely visible, impossible to touch, but written into the oldest light like faint scratches beneath the varnish of an ancient painting. The universe's oldest light is a memory. The cosmic microwave background, the soft, nearly uniform glow that fills the sky, was released when the universe was only 380,000 years old. That light is the oldest photograph ever taken, a portrait of the cosmos as a newborn, but some theories suggest it may also contain fossils from even earlier epochs, signals that were baked into space-time itself before the fireball cooled enough to shine. Imagine ripples frozen in ice. Even if the ice melts and refreezes, the faintest contours remain memories of forces that acted long before the surface solidified again. The universe may work the same way. Subtle patterns, too large to explain. When cosmologists map the cosmic microwave background, they find it is astonishingly smooth. But in the fine grain deep in the noise pattern lie anomalies that do not quite fit the standard model. Tiny cold and hot spots larger than they should be, curious directional alignments, temperature variations that seem statistically improbable, asymmetries between hemispheres. These features are subtle, so subtle that many argue they are mere statistical quirks. But others whisper, what if these are the scars? What if these anomalies are the fingerprints of whatever came before? Cosmic bruises, a universe that hit something. One idea is that our universe may have collided with another bubble universe in the early moments of inflation. Such a collision would leave a faint circular bruise on the cosmic microwave background, a barely perceptible ring colder or warmer than the surrounding region. Some teams claim to have found hints of such rings, others dispute them. But the thought remains intoxicating that our universe may have bumped shoulders with another reality long before its own structure had fully formed. Two cosmic balloons grazing each other in the dark, echoes from a previous cycle. Another possibility is cyclic cosmology, the idea that the universe undergoes endless expansions and contractions. In this view, the Big Bang wasn't a beginning, but a transition, like waking from a long sleep. If that is true, then gravitational waves or density patterns from a previous universe could imprint themselves onto ours. The cosmic microwave background might contain faint streaks caused by relic gravitational waves, repeated shapes, echoes of ancient structures, minute alignments like fingerprints pressed through layers of cosmic paper. We would be reading the final whispers of a world that ended before our own began. Quantum scars in the fabric of space-time. At the smallest scales, space-time may have been tossed and churned by quantum fluctuations so violent that they left permanent distortions, tiny wrinkles stretched across the cosmos when inflation blew space outward. These wrinkles would be invisible to the naked eye, but detectable in the microwave background's statistical patterns, like creases in cloth ironed smooth, but never fully erased. In this sense, the Big Bang did not erase the past, it merely blurred it, and inflation stretched those blurred markings across the sky. The universe remembers. Perhaps the most poetic idea is that space-time itself holds memory, that the curvature, the distribution of energy, the primordial fluctuations, all are shaped not only by the Big Bang, but also by conditions that existed before it. Our universe may not remember the details, but it remembers the rhythm, the texture, the faint outline of the events that gave birth to it, like a dream half forgotten upon waking, yet lingering in the tone of the day. A quiet meditation on ancient echoes. As you settle deeper into rest, imagine the night sky as a vast parchment stretched above you. On its surface lies the soft glow of the cosmic microwave background, a whisper of heat from the first moment the universe released light. But beneath that glow, hidden in the faintest variations, are older marks, subtle rings, gentle asymmetries, long wavelength ripples, ghosts of worlds we will never see, echoes of events older than time as we know it. These are the universe's scars, not wounds, but memories. Perhaps our cosmos is like a person who survived a great transition carrying quiet traces of its former life. We see only hints, a slightly warmer patch, a slightly cooler blot, a curious alignment of patterns, a deviation so small you'd miss it unless you stared for years. And yet together these faint marks tell a story that the universe may have a history deeper than the Big Bang, that existence did not begin from perfect silence, and that even creation carries echoes of what came before. Let that mystery hold you gently. Let it remind you that the cosmos, like all things, has a past it cannot fully remember, but one it never fully forgets. You too are part of that ancient memory, a ripple in a universe that has lived through more than it can say. When we map the galaxies across billions of light years, the picture looks almost organic. Not random, not chaotic, but delicately arranged into filaments, nodes, and vast empty basins that resemble living structure. From afar, the cosmic web looks like the branching of nerves in a human brain, the tangled roots of a forest, the mycelial lacework beneath a meadow, the fine cracks in ancient ice, the filigree of blood vessels spreading through a body. Patterns echo across scales so wildly different that they defy intuition. Something in the universe seems to favour certain shapes, as if matter, when given time and gravity, paints with a recognisable brushstroke. Symmetry on cosmic scales. When astronomers analyse the distribution of galaxies, they find hints of deep order filaments aligning in similar orientations across vast distances. Walls of galaxies forming sweeping sheet-like structures, spherical clusters arranged like beads on gravitational threads, voids laid out as if respecting an unseen grid. These aren't perfect symmetries, the universe is too wild for that, but they're statistical symmetries, patterns that emerge only when you look at millions of galaxies at once, like seeing the grain in wood or the weave in fabric. It's as though the universe organises itself with a quiet rhythm. Gravity as the great sculptor. Gravity doesn't just pull, it sculpts. Over billions of years, tiny variations in density grew into massive structures, filaments connecting clusters like tendons, nodes where galaxies gather like synapses, voids expanding like great breaths of emptiness. You can think of the universe as a kind of three-dimensional mandala carved slowly by the patient hand of physics. Mathematics beneath the stars. Deep inside this structure hides an elegant mathematical relationship. Patterns called power spectrums, correlation functions, tilts and scale invariant fluctuations all hint at a profound simplicity beneath complexity. The universe on its largest scales behaves like a single connected entity, following laws written in graceful equations. Imagine looking at a fern leaf repeating its shape at smaller scales, a snowflake displaying symmetry across every branch, ripples spreading evenly across a pond. The cosmic web echoes these natural harmonies not through crystals or fluids, but through galaxies and dark matter. Neural networks. Across light years. One of the most striking comparisons is between the cosmic web and the structure of the brain. Not because they are literally the same, but because their architecture is eerily similar. Long filaments, axons connecting nodes, neurons. Regions of intense clustering separated by vast empty spaces. Pathways for the transmission of information, in one case electrical, in the other gravitational. A global pattern emerging from countless local interactions. Astronomers and neuroscientists have even shown that the distribution of galaxies and the distribution of neurons share comparable statistical properties. It is of course a coincidence, but a poetic one, as if the universe mirrors itself at every scale, from the firing of synapses inside a skull to the glowing of galaxies in the dark. Biological echoes in the dark. Think of a tree's branching limbs. Think of a lightning bolt corkscrewing across the sky. Think of frost spreading across a window pane. All are governed by physical rules that encourage branching, splitting, clustering, flowing. And the universe, by way of gravity and dark matter, follows similar principles. The cosmic web is not alive, but it behaves like systems that are alive. It grows in patterns we instinctively recognize, a universe that organizes itself. Why does matter arrange itself this way? Why filaments and not blobs? Why clusters and not clouds? Why voids and not smooth fields? Because gravity favors connections. Because the early universe seeded the right fluctuations. Because dark matter acted as a scaffold. Because time allowed structure to unfold like a blooming flower. There is a gentle inevitability in these patterns, a sense that the universe tends towards shapes that feel familiar to us, even though they arise from entirely alien mechanisms. A meditation on hidden order. As you relax into the quiet, imagine drifting above the cosmic web, billions of galaxies glowing like sparks embedded in a vast branching structure. It looks almost fragile, as delicate as spider silk or frost crystals. Yet it stretches across unimaginable distances, tying the cosmos together with threads of gravity and time. Picture the filaments as rivers of starlight. Picture the nodes as cosmic cities. Picture the voids as silent valleys of darkness. And imagine that all of it, every pattern, every shape, is the magnified echo of tiny quantum ripples from the universe's first moments. From those invisible tremors grew a web so large it could hold all of existence. Let that vision soften your mind that beneath the universe's apparent chaos lies hidden organization, deep symmetry and patterns that speak to something ancient within us, the part that recognizes order, the part that feels connected, the part that senses meaning in structure. You're a tiny neuron in that cosmic network, a flicker in the grand architecture of space, a small point of awareness woven into the universe's intricate design. And tonight, as you drift toward rest, you're drifting within that quiet web, held gently by its symmetry, cradled by its structure, and connected to everything by threads of gravity and light. Every universe, like every life, carries within it the possibility of endings, not immediate, not looming, but written softly into the laws that shape its evolution. And when we look far into the future, trillions of years ahead, long after every star you know has faded, cosmology offers a set of possibilities. Not prophecies, but scenarios, each one a meditation on impermanence. The universe may cool into silence, it may tear itself apart, it may collapse inward and begin again, or it may choose a path stranger than anything we have imagined. 1. Heat death. The universe drifts into stillness. This is the gentlest and most widely accepted fate. Dark energy continues its steady push, accelerating the universe's expansion. Galaxies drift apart until no light can cross the void. Stars burn out, white dwarfs fade, black holes evaporate. Eventually all processes wind down. No heat flows, no structure changes. Time still exists, but nothing happens in it. A vast, quiet universe filled with cold particles, and nothing more. There is sadness in this vision, a cosmos falling asleep, a fire slowly dying. But there is peace too. Like the final embers of a campfire glowing softly under a dark sky, The universe would not end violently. It would simply exhale its last warmth and rest. In that quiet, we find a strange comfort. Even stars are temporary. Even galaxies get weary. Everything burns for a while, then gently cools. 2. The Big Rip, the universe tears itself apart. If dark energy grows stronger with time, not constant but increasing, then expansion will accelerate uncontrollably. Galaxies will fly apart. Stars will be torn from their systems. Planets will drift into isolation. Then closer to the end, solar systems will dissolve. Atoms will stretch and tear. Even the fabric of space will unravel. This sounds terrifying, but on cosmic timescales it is slow, almost graceful, like threads being pulled from a woven cloth. Everything we know unravels into a final bright release. There is a strange beauty in this vision, the universe returning its matter, its energy, its very structure to freedom. Nothing remains bound. Everything expands into pure openness. In this scenario, the universe does not die quietly. It transforms from structure to scattering, from form to pure expansion. 3. The Big Crunch. The universe falls back into itself. If dark energy reverses or weakens, gravity may take over. Galaxies will stop drifting apart and begin to converge. Stars and clusters will gather like leaves pulled inward by a tide. The universe will heat again, light will blue shift, matter will compress. Eventually everything collapses into a single dense state, a mirror of the Big Bang but happening at the end rather than the beginning. This could be catastrophic, but also cyclical, rhythmic, a heartbeat of cosmic scale. In some theories, the Big Crunch leads to a new expansion, a new universe, a new beginning. A cosmic inhale followed by a cosmic exhale. Endings in this view are never final. They are transitions, gateways from one universe to the next. 4. A stranger fate. Something we haven't imagined. The universe often surprises us. Dark energy may change its nature. Quantum fields may shift. Higher dimensions may influence our cosmic evolution. We may discover forces or dynamics that rewrite every prediction we hold. Our universe may fade or ripple or cycle or tunnel into another state. It may stabilize in a way we cannot yet understand. The only constant is that change will come, but change need not be feared. A meditation on cosmic impermanence. As you lie here in a moment so small compared to cosmic time, it is easy to feel fragile, as if these grand fates diminish our place in the universe. But in truth, they highlight something profound. Everything changes, everything flows, everything transforms, stars end, galaxies disperse, universes evolve. But within these transitions, meaning persists, not because things last forever, but because they exist at all. Your life is a brief moment in the universe's story, but it is a moment filled with awareness, emotion, memory, and connection. The stars themselves are impermanent, yet their light warms our nights. Galaxies will one day fade, yet their beauty moves us. The universe may one day sleep, yet right now it is alive and bright, and you are here to witness it. Endings as soft transformations. Every cosmic fate is not a death, but a shift. Heat death is a fading into quiet. The Big Rip is a release into openness. The Big Crunch is a return home. Unknown fates are invitations to wonder. Whatever the universe becomes, it will be a continuation, a new chapter, not a final page. Let that settle gently within you. Let it dissolve worry and replace it with awe. The future of the cosmos may be vast and strange, but its changes are part of a natural, graceful flow, and you resting here tonight are a fleeting but meaningful flicker in a universe that has been transforming since the beginning, and will continue to transform long after the last star has dimmed. Endings are not failures. They are transitions, moments of becoming, steps in a journey without a final destination. Let the cosmos cradle you in that truth. We live in a luminous universe, or so it seems. Stars shine, galaxies swirl, nebulae glow in delicate ribbons of colour, and yet the light we see is only a sliver of what truly exists. More than 95% of the cosmos is invisible, made of things we cannot touch, cannot hold, cannot shine light upon. A universe where the majority hides in shadow. This chapter is a journey into that hidden realm, a single, coherent exploration of dark matter, dark energy, and the possibility that entire cosmic architectures exist beyond our senses. The dark cosmos, astrophysicists sometimes describe our universe as an iceberg. The bright part above the waterline is ordinary matter atom stars U. But beneath the surface stretches a mass far greater, far stranger, silently shaping everything. Dark matter pulls galaxies together, dark energy pushes them apart, and beyond both may lie unknown shadow sectors siblings to the matter we know. We do not see this dark cosmos. We feel it through gravity, through expansion, through structure. Dark matter. The hidden scaffold galaxies rotate too fast to be held together by the stars we see. Clusters move as if dragged by invisible hands. Light curves around regions where nothing appears to sit. Something massive but unseen forms the skeleton of the universe. Dark matter is not a single thing. It might be a family cold dark matter, slow massive particles forming cosmic scaffolding. Warm dark matter, lighter faster smoothing small scales. Ultralight dark matter forming vast quantum waves. Self-interacting dark matter creating hidden collisions and pressure. Sterile neutrinos, ghost-like particles barely engaging with reality. Some theories go further. Dark atoms may exist particles forming dark molecules. Dark chemistry, even dark clouds. If dark matter interacts with itself through forces we cannot detect, it may create structures as rich and varied as those in our familiar world. Dark stars, dark galaxies, dark webs overlapping ours like a ghostly twin. We would never see them, but their gravity would whisper through our universe like wind passing through unseen trees. Dark energy, the quiet expansion. If dark matter holds the universe together, dark energy tears it apart. It is the invisible pressure accelerating cosmic expansion, causing galaxies to drift away faster and faster. But dark energy may not be constant. Some models propose that it changes over time, oscillates like a cosmic tide, weakens or strengthens depending on the universe's age, interacts with dark matter in ways we have not imagined. Perhaps dark energy is a field that breathes slowly swelling and shrinking through the eons, or a property of space-time itself shifting quietly beneath the cosmic fabric. Shadow forces and dark sectors. Physics does not forbid the existence of entire families of particles that never interact with light. They might obey their own forces, their own versions of electromagnetism, nuclear bonding, or cosmic pressure. Imagine a dark electromagnetic force binding dark particles, a dark nuclear force creating stable dark elements, dark radiation flowing unseen through space, dark light shining in a spectrum we can never detect. These forces could form a shadow sector, a parallel physics woven through our own, but never touching except through gravity. Space-time may be hosting two overlapping universes, each unaware of the other's details, bound only by the pull of mass, multidimensional interactions. Some theories propose that dark matter or dark energy might be fingerprints of higher dimensional processes. Perhaps gravity leaks into extra dimensions. Dark matter dwells partially outside our universe. Dark energy is the tension of a higher dimensional membrane. Our cosmos is one sheet drifting in a stack of universes. In these views, the dark cosmos is not simply invisible, it is partly elsewhere. We see shadows, not substance. Impressions, not forms. Dark stars, dark halos, dark architecture. If dark matter can clump cool or interact, then entire hidden architectures might exist, dark halos cradling galaxies, dark disks rotating inside spiral galaxies, dark stars powered by annihilation instead of fusion, dark black holes formed from dark matter collapse, dark galaxies drifting through space affecting visible matter only through gravity. These structures would not glow. They would not absorb light. They would not reflect it. They would not reveal themselves through any electromagnetic signal. They would be felt only through gravitational tug, like invisible cities shaping the traffic of stars. A universe that is mostly hidden. Ordinary matter, everything we know, is a minority, a special case, a luminous exception. The majority of the cosmos is quiet, dark, and elusive. It shapes galaxies, bends, space-time drives, expansion, and defines cosmic destiny. And yet, we see none of it directly. A meditation on the hidden majority. As you drift deeper into stillness, imagine lying beneath a vast night sky. The stars sparkle, the Milky Way glows, but you know quietly that the true structure of the universe lies in darkness. Imagine the cosmic web you cannot see, threads of dark matter, cradling galaxies like beads on invisible string, vast halos cocooning clusters, soft tides of dark energy pushing everything apart with gentle persistence. Picture these unseen forces as a second universe overlapping our, a silent companion, a shadow twin moving in rhythms we barely understand. You're made of starlight, but you live inside a universe made mostly of darkness. Invisible currents surround you, invisible architectures hold you, invisible energy shapes your destiny, and in that darkness there is wonder, mystery, possibility. The cosmos is larger than sight, larger than matter, larger than everything we know, and you resting here tonight are floating in a sea of invisible forces held gently by the gravity of what cannot be seen, carried by the expansion of something that has no face and part of a universe whose majority hides softly in shadow. The dark cosmos is not an absence. It is a presence quiet, patient, and profound. Let that truth cradle your imagination. Let it soothe you. Let it expand around you like a gentle, unseen sky. Black holes sit at the very edge of what reality allows, or perhaps just beyond it. They are places where matter collapses into such a tight knot that space and time themselves can no longer continue as they were. Places where the rules break or bend or reveal layers we never suspected. In the quiet dark of a black hole, the universe stops pretending it is simple. Where gravity folds the world inward. A black hole begins with collapse, a star's core crushed under its own weight, or perhaps a dense region in the early universe shrinking into a point. Gravity intensifies until no force can resist it. Space curves inward, time slows, light struggles. At some boundary, the event horizon escape becomes impossible. Not difficult, not unlikely, impossible. Beyond that horizon lies a region where our equations falter, where the familiar logic of reality dissolves. Not because it is magical, but because it is too extreme. Black holes are the universe's confessional silent chambers, where matter whispers its last secrets before disappearing from view. The singularity, or something else. At the center of a black hole lies the most mysterious possibility, the singularity, a point of infinite density where the curvature of space-time diverges. But infinities in physics are often signs of missing understanding, warnings that the map ends there. Some theories suggest alternatives, quantum cores, where matter is compressed but not infinitely, Planck-scale spheres where space becomes grainy and cannot shrink further, exotic states of matter stabilized by quantum pressure, bounce points where collapse triggers expansion into another region of space-time. Whatever lies inside is hidden forever from our view. The universe keeps its deepest truths locked behind the horizon. Black holes as gateways. In mathematics, black holes hint at something astonishing. They resemble the opening of wormholes, tunnels connecting distant regions of space or even different universes. Whether these tunnels can exist in reality remains unknown. They may require exotic matter or perfect symmetry. They may collapse instantly. They may tear anything that enters into pure energy. But the idea lingers that a black hole might not be an ending but a doorway, a cosmic passageway carved by gravity's relentless hand. The information paradox, nothing is truly lost. One of the most profound puzzles in physics arises from black holes. When something falls in a planet, a photon, a single particle, the black hole seems to erase all details, except mass charge and spin. All other information is gone, destroyed. But quantum mechanics forbids destruction of information. Reality is not allowed to forget. So what happens to the details of what fell in possibilities, including coded on the event horizon as holographic patterns, released slowly through subtle correlations in Hawking radiation, preserved in a remnant after evaporation, transferred into another region of space-time? Black holes are cosmic diaries. They record everything that enters even when they appear silent. Evaporation, the slow fade through Hawking radiation. Black holes radiate tiny amounts of heat, not enough to notice for large ones, but over unimaginable timescales they shrink, lose mass, dim, flicker. A supermassive black hole may last for 1090 years or more, slowly evaporating into a final burst of light. Even these titans are impermanent. Even darkness fades. Primordial black holes. Ancient seeds. Some black holes may not come from dead stars. They may have formed in the earliest instance after the Big Bang, tiny pockets of dense matter collapsing at the universe's violent birth. These primordial black holes could range from the size of mountains to the size of atoms. They could drift invisibly through galaxies, make up part of dark matter, seed early galaxies, exist in vast hidden populations. We may be surrounded by ancient black holes older than any star, hidden populations in the cosmic dark. Most black holes are invisible. They do not shine. They move silently, warping space as they pass. There may be millions of stellar mass black holes drifting in the Milky Way, wandering giants exiled from galactic centers, intermediate mass black holes hiding inside globular clusters, rogue black holes drifting between galaxies, each one a silent gravitational well unnoticed until it passes near a star or gas cloud. A meditation on the unreachable. Tonight, imagine standing at the edge of a black hole, safely at an impossible distance where light still flows. The horizon is not a wall. It is a one-way veil, a boundary where time slows to a crawl. Inside, the universe folds inward like a letter sealed shut. Matter confesses its secrets in a language we cannot read. Light curves inward like a whisper being swallowed. Black holes are not monsters. They are monuments to extremes, reminders that the universe is not obligated to stay within the bounds of our intuition. They are cosmic confessionals where matter speaks its final truths, cosmic mirrors reflecting the limitations of our understanding, cosmic wells where reality bows its head and admits mystery still remains. And in their darkness, there is beauty. There is humility. There is the quiet knowledge that the universe is deeper, stranger, and wiser than the laws we have written so far. As you drift into rest, let that mystery wrap you gently. The idea that somewhere far across the stars, gravity builds rooms where space folds time, slows light, kneels, and the universe hides its most intimate secrets. Neutron stars are the densest, strangest objects the universe allows before the curtain drops into a black hole. A spoonful of their material would outweigh a mountain. A thimbleful would crush a city. A single breath taken on their surface would require surviving a gravity so intense it warps the space around you and drags time to its knees. They are not stars in any familiar sense. They are matter beyond matter objects so extreme that atoms themselves collapse, and the universe reveals a hidden texture usually locked away inside protons and neutrons. A star, remade by pressure. When a massive star dies, its core collapses until electrons are forced to merge with protons forming neutrons. The result is a sphere no larger than a city, maybe 20 kilometers wide, containing more mass than the sun. Standing on its surface, if standing were possible, would be like balancing on the skin of a pressure god. Gravity is so fierce it would crush your body into a layer a few atoms thick in an instant. Light itself bends into near orbit, skimming just above the crust. Everything here is extreme. Time, matter, physics, silence, exotic, interiors, quarks, hyperons, something stranger. Inside matter is squeezed into forms that do not exist anywhere else. Neutron superfluid swirling with zero friction. Proton superconductors carrying currents that never fade. Hyperon strange matter cousins of neutrons. Quark matter where neutrons dissolve into a soup of up-down and maybe strange quarks. Color flavor locked phases, a possible crystalline arrangement of quarks. These possibilities are not science fiction. They are the best guesses of nuclear physics pushed past its limits. A neutron star may be layered like an impossible fruit, a thin iron atmosphere, a crust of neutron-rich nuclei, a deeper region where nuclei dissolve, a superfluid neutron ocean, a core of quark matter or something we do not yet have a word for. Imagine holding a stone that contains not just matter, but post-matter compressed into its most extreme and unfamiliar form. The crust. The strongest material in the universe. Around the outside lies a crystalline crust, a lattice of atomic nuclei packed so tightly and so rigidly that it forms the strongest material known. Experiments suggest it is 10 billion times stronger than steel, capable of supporting mountains only centimeters tall yet weighing as much as Everest, able to crack violently, producing starquakes that shake space-time itself. When the crust shifts, the entire star shivers. We detect these tremors as bursts of gamma rays or sudden changes in rotation. Glitches, a star that stumbles. Neutron stars spin with unfathomable speed, some rotate hundreds of times per second. Their magnetic fields are trillions of times stronger than Earth's, but every so often their spin suddenly jumps a phenomenon called a glitch. It's as if the star hiccups or slips or stutters. These glitches may be caused by superfluid regions inside snapping into alignment, crustal quakes jerking the star's rotation, vortex lines rearranging in the internal superfluid. Imagine a spinning ice skater whose muscles twitch into a new position at unimaginable density and speed. Unknown emissions, light from nowhere. Some neutron stars produce bursts we cannot explain, repeating mysterious radio pulses, millisecond flashes of X-rays, gamma-ray storms lasting only a heartbeat, odd spectral lines that hint at unknown particles. These signals appear and vanish without warning, like tapping on a cosmic window from the dark side of physics. Neutron star mergers, cosmic alchemy. When two neutron stars orbit each other, they spiral inward over millions of years, finally colliding in a spectacular explosion called a kilonova. In that instant, the universe becomes an alchemist. Gold is created, platinum is forged, uranium and rare elements are born, gravitational waves ripple across space-time. Every gold ring, every ancient coin, every gleaming artifact on Earth contains the ashes of two neutron stars that died in a single brilliant instant long before the sun was born. Planets around neutron stars, the impossible survivors, and in the silence that follows these deaths, something miraculous can happen. Planets can form again. Neutron star planets exist. They orbit pulsars like dark marbles, warmed not by sunlight, but by radiation and magnetic fury. Some are made of diamond-like carbon compressed into crystalline spheres. Others may be fragments of stars or debris disks sculpted into new worlds. Imagine a planet circling a corpse star lit not by daylight but by radio pulses sweeping across space like the heartbeat of a sleeping giant. A sensory descent into the strange. Close your eyes and imagine standing near one of these objects from an impossible vantage. You feel pressure like a presence, not a force, a weight that exists everywhere, pushing inward on your mind. You sense density far beyond anything Earth can teach you, matter so compact it feels like touching the essence of existence. You hear silence deep and ancient, touched only by the faint ticking of millisecond pulses sweeping across the cosmos like a metronome in the dark. The neutron star hums, not audibly, but in the language of gravity and radiation. Its presence is overwhelming, like standing beside the universe's beating heart, a heart made not of flesh, but of crushed atoms and superfluid matter, matter beyond matter. Neutron stars are the last stop before reality breaks entirely. They are the halfway point between existence as we know it and the complete surrender of matter into a black hole. They show us that even inside the universe's most extreme conditions there is structure, behavior, rhythm, a strange choreography performed by physics at its limits. As you drift towards sleep, let yourself imagine that dense, quiet world, the pressure like the weight of all time, the density like the memory of stars, the strangeness like a dream, the universe once had and kept secret. You, a being of soft atoms and gentle forces, are lying in a universe where such impossible objects exist. Crushed matter, superfluids, quark seas, and spinning corpses that shine like lighthouses in the abyss. Let that wonder settle over you like a blanket. Let it remind you that even in the most extreme corners of reality, beauty persists patient, strange, and luminous in its own way. Far beyond the planets, past the orbits of Neptune and Pluto, past the realm where sunlight still has warmth and the solar wind still has strength, lies a region we have never seen, a region not one telescope has ever photographed, not one probe has ever touched. The outer dark of our solar system. Here our knowledge ends and imagination begins. The sun's light fades into a thin whisper. Temperatures sink toward absolute cold, and objects, if they are there, drift through darkness so complete that they have escaped detection for the entire history of astronomy. The comets, secret birthplace comets, arrive from this region like messengers from a forgotten age. Some sweep inward along graceful arcs, warming into glowing tails. Others arrive suddenly on orbits so long and stretched that they may not return for millions of years. These ancient wanderers point toward an invisible structure, the Oort cloud, a vast spherical reservoir of icy bodies surrounding the solar system like a shell. We have never seen a single one of its members, not because they are not there, but because they are too small, too dark, too cold, too distant. A trillion frozen worlds drifting in silence, each one dimmer than the faintest galaxy. The invisibility of the Oort cloud. If the solar system were a house, the planets would fill the living room. Beyond them lies a hallway, the Kuiper belt. Beyond that, the attic, the scattered disk, and the Oort cloud. It would be the fog stretching miles beyond the walls, a sphere so vast that even our most powerful telescopes cannot find its edges. The Oort cloud may extend halfway to the nearest stars, contain icy bodies the size of mountains, hold fragments from the solar system's birth, include objects captured from other stars long ago. It is a frozen archive drifting at the border between home and interstellar wilderness. Invisible clouds, beyond the reach of light dust and ice particles, fill these outer regions, tiny grains, scattered across space like cold ash from an ancient fire. Individually they are nothing. Collectively they form unseen structures, faint rings, ghostly arcs, dark filaments. Clouds of material so thin we detect them only by how they block starlight. Our solar system is not a clean, empty bubble. It is wrapped in layers, some bright, many hidden, of drifting ancient debris. Rogue objects passing through. From time to time something stranger appears, a rogue, like Oumuamua slicing through the inner solar system with no tail, no glow, no gas, a shard from another star system. Or Borisov, a true interstellar comet, whose chemical signature did not match anything in our own cosmic neighbourhood. The outer dark is not empty. It is a crossroads, a place where travellers pass silently unseen unless their path happens to cross our thin beam of sunlight. Some may be remnants of shattered planets, others may be icy bodies ejected from distant stars. Some may drift for billions of years before touching any system at all. The outer dark is a borderland where the solar system ends and the galaxy begins. Interstellar dust, a hidden architecture. Between the stars lies dust so faint it is almost imaginary, yet dense enough across vast distances to form structures, filaments stretching light years, wisps shaped by magnetic fields, cold clouds drifting like ancient smoke, dusty rivers carved by galactic tides. When the solar system moves through these regions, the outer dark responds. Particles drift inward, the heliosphere shifts, cosmic rays slip through cracks in the sun's magnetic shield. The border is not static, it breathes. Frozen reservoirs, waiting in silence. Out in the extreme cold, a cold so deep that atoms barely move, ices preserve the chemistry of the early solar system water. Methane, ammonia, carbon monoxide, organic molecules older than Earth. Every comet that falls inward brings a frozen memory, a sample of the solar system, as it was 4.5 billion years ago, carried from the outer dark like a message thawing in sunlight. Atmospheric imagery of the far black. Imagine drifting outward past the planets, Jupiter fading behind you like a dim lantern, Saturn's rings dissolving into shadow, Neptune shrinking into a pale dot, Pluto vanishing into the void. Past that point there is no colour, only a darkness. The sun becomes a bright star among many. Its warmth thins into an invisible thread. Space grows colder than anything you can imagine. Tiny icy bodies float in silence. Dust dances gently in the starlight, leaking in from afar. Every direction stretches into night. This is the solar system's frontier, not a place of planets and moons, but a place of shadows and whispers. A meditation on the outer dark. As you rest tonight, imagine the slow, patient darkness beyond the last orbit. A cold ocean of nothingness filled with unseen worlds, drifting like frozen seeds. Silence deeper than space near Earth. Stillness older than any planet. Out there nothing moves quickly, nothing glows, nothing announces itself. And yet this distant dark holds the origins of comets, the traces of ancient chemistry, the fingerprints of interstellar dust, and perhaps the quiet signatures of worlds we have never imagined. The solar system is not just a clockwork of shining planets. It is a sphere wrapped in darkness, cradled by invisible clouds, visited by passing wanderers, and watched over by the thin, fading breath of sunlight. You are lying on a small planet inside a warm, bright inner room, but beyond that room stretches a cold, beautiful, endless frontier. Let that vastness calm you. Let that silence settle around you. Let the outer dark remind you that even in the coldest reaches of existence, mystery endures patient quiet and waiting. Between the stars lies a realm that seems empty when viewed from afar, a thin ocean of gas and dust stretching across light years, faint enough that a grain of sand placed in your hand contains more atoms than some cubic meters of interstellar space. And yet this emptiness is alive with hidden architecture. Invisible forces weave through it. Whisper thin waves travel across it. Rare molecules drift and assemble in the dark. Structures form, fade and reform like tides in a shadowed sea. Interstellar space is not a void. It is a cosmic ocean full of motion, structure and quiet mystery. Magnetic fields. The hidden skeleton of the galaxy. Threading through this vastness are magnetic fields, not the sharp, strong fields of a magnet in your hand, but gentle, pervasive currents that guide dust, shape gas clouds, and steer charged particles. These magnetic fields twist through spiral arms, thread filaments like cosmic ropes, wrap around molecular clouds, align dust grains so faintly that only polarized starlight reveals the pattern. To human eyes, the galaxy seems like stars scattered randomly. But beneath the surface lies a magnetic skeleton, subtle but essential, the hidden framework upon which much of interstellar structure rests. Waves in the galactic sea. Just as the ocean carries swells and tides, interstellar space carries waves, soft undulations of density, pressure, and magnetic energy. Alpha waves rippling along magnetic lines, sound waves traveling through cold gas clouds, shock fronts from dying stars expanding across light years, cosmic ray winds shaping the flow of matter. These waves move at different speeds, some slow as drifting sand, others fast as a whisper of light. They sculpt the medium, pushing dust into filaments, gathering hydrogen into knots where stars may one day ignite. Exotic molecules in the dark. In the cold, quiet spaces between stars, chemistry takes on new forms. Icy grains and thin gas clouds craft molecules that cannot survive on Earth. Long carbon chains, exotic nitriles, prebiotic molecules, polycyclic aromatic hydrocarbons, complex organics that hint at the chemistry of life. Some molecule clouds span dozens of light years, dark laboratories where atoms drift, meet, bond, and separate in the silence. Interstellar space is a slow alchemist, working in temperatures near absolute zero, shaping matter grain by grain into something new. Transient structures, shapes that come and go. The interstellar medium is not static. Structures rise and dissolve continually, wispy tendrils illuminated only by starlight, sheets of dust like cosmic parchment, hollow bubbles carved by supernovae, tunnels shaped by stellar winds, faint bridges of gas connecting star-forming regions. These forms can last millions of years or blink out in thousands, ephemeral on cosmic timescales, yet grand in scale and beauty. Picture fog stirred by unseen winds forming shapes that shift slowly across centuries. Unexplained interstellar phenomena. In this dim ocean, some signals remain mysteries. Sudden, powerful radio bursts lasting milliseconds. Unexplained repeating pulses. Drifting filaments with no clear origin. High-energy particles arriving from unknown sources. Strange glow patches where no stars exist. Interstellar space is full of phenomena that don't obey our expectations, pulses, flares, hums, shadows. Not dangerous, not violent. Simply unknown. Like faint lights seen across a foggy sea, their meaning flickers at the edge of understanding. The cosmic ocean, a gentle exploration. Imagine drifting through interstellar space as if sailing through a soft, dark ocean. The sun becomes a distant beacon, shrinking into a pale point of light. Around you, the medium seems empty but slowly reveals itself, faint currents of charged particles brushing past. Magnetic lines twisting like unseen tides. Dust motes drifting like cold embers. Long ripples in hydrogen clouds shimmering in radio waves. You float between stars surrounded by the quiet architecture of a galaxy, a place where forces flow without sound, where waves travel without surface, where structures rise from darkness and dissolve into deeper silence. A meditation on the hidden order between stars. Tonight, as you settle into rest, imagine the calm expanse between suns. Not empty, but delicately structured, a vast ocean of subtle forces and drifting matter. Breath by breath, picture magnetic fields weaving like soft threads, waves rolling silently in enormous arcs, molecules forming like tiny notes in a long cosmic melody, dust filaments stretching like faint rivers, radio whispers folding through the dark. This is the interstellar sea, the quiet space in which stars are born, drift and die. You're part of a solar system floating within that ocean, held gently by invisible forces older than planets, older than stars, older than light itself. Let the vastness soothe you. Let the quiet structures calm your mind. Let the hidden architecture remind you that even what appears empty is full of possibility, full of patterns, currents and soft designs felt only at the edges of perception. You drift through this ocean every moment of your life, carried by its currents, protected by its magnetic tides, surrounded by the soft, invisible beauty of interstellar space. Most worlds live in orbit, steady circular rhythms around suns that warm them, anchor them, define their years. But not all worlds belong to such tidy systems. Some wander, some drift through the galaxy alone, without sunrise or sunset, without seasons, without a parent star to steady their path. Some pass silently through other systems barely noticed. Some lurk in the outskirts of our own solar system, following strange elongated paths no planet should follow. These are the rogue objects and wandering worlds, the cosmic nomads that travel without a home. Visitors from the deep galactic night. The first we ever saw was Oumuamua, a dark shard slicing through our solar system at a speed too great for any object bound to the sun. It tumbled strangely, reflected light oddly, accelerated in a way we still cannot fully explain. Not a comet, not an asteroid, not like anything we had catalogued before. It arrived unannounced, crossed the inner solar system in a matter of weeks, and vanished again into the dark, a traveller from a distant star carrying secrets we could not decipher. Then came Comet Borisov, icy and alien its chemistry, unlike any comet born in our solar system. A second visitor, a second reminder that the galaxy is full of wanderers. These objects do not belong to us. They are passing through like strangers walking briefly through our field of view. Unseen bodies on the fringe. Even within our own system, not everything is settled. Far from the sun's warm glow, some icy bodies follow odd lopsided orbits, as if pulled by something massive, something distant, something hidden. Some astronomers call it Planet 9 a super-Earth, drifting on an orbit so huge it takes tens of thousands of years to complete. Others believe the pattern could be caused by a cluster of smaller unseen worlds, or by a rogue planet captured long ago, or by features of the galaxy itself tugging at the solar outskirts. We cannot confirm it yet. The outer dark hides its secrets well, but something out there is shaping the dance of distant objects, something heavy, something slow-moving, something quiet. The lonely worlds, between stars beyond our solar system, between the spiraling arms of the Milky Way, wander rogue planets, worlds that were thrown out of their birth systems, ejected by violent gravitational encounters, orphaned when their stars died. Born in isolation from clouds too small to ignite fusion, there may be billions of these worlds, each a dark sphere drifting through a cold eternal night. Some may host oceans warmed by internal heat. Some may retain thick atmospheres. Some may have moons, rings magnetic fields, entire miniature systems wandering through emptiness. Imagine a world with no sunrise, a sky without stars, only darkness and the soft glow of internal warmth. Strange trajectories, stranger stories. Not all wanderers follow straight paths. Some move as if pushed by unseen forces, objects nudged by interstellar magnetic fields, worlds perturbed by passing stars, icy bodies kicked by galactic tides, fragments of supernova hurtling across space. A few move so quickly they may be hypervelocity planets flung outward by supermassive black holes, at speeds that could cross the galaxy in a single lifetime. Others travel slowly, drifting like dandelion seeds, carried by gentle cosmic winds. Every one of them has a story, a past, a reason they wander. Cosmic wanderers as messengers. When an interstellar object enters our solar system, it brings with it tiny clues, unfamiliar chemistry, alien dust, exotic isotope ratios, strange shapes, odd reflections of starlight. Each visitor is a message from somewhere else, a fragment of another star's neighborhood, a piece of another system's history, a shard of a world we will never see directly. Most of the time we miss them. They slip through silently undetected. But now and then one crosses our path, and for a moment the universe feels larger, stranger, more connected. A gentle tension, the unknown passing. Nearby, imagine lying awake at night knowing that out there just beyond the planets, worlds move through space with no star to anchor them. Some pass close, cosmically close, without us ever knowing. Some may drift within a few light years, silent giants in the dark. There's a soft thrill in that thought, a gentle tension. Not fear, but awareness. A feeling that the universe is more dynamic than it appears, full of passing shadows whose stories remain untold. A meditation on wanderers. Tonight, picture the vast black between stars, a darkness so deep it feels like velvet. Now imagine a solitary planet drifting through that darkness. A world with frozen oceans, silent valleys, mountains lit only by starlight too faint to warm them. No sun, no seasons, just eternal night and a slow journey through the galaxy. Then imagine another wanderer, a shard of rock, a block of ice, a comet from a star you will never know, slipping silently into our solar system. It glides past planets that glow in sunlight, skims through the inner system, and arcs away again into emptiness. Wanderers come and go, some leave traces, some vanish without a sign, some stir the orbits of distant objects, leaving gravitational fingerprints we can detect centuries later. The galaxy is not static. It is a place of motion, of visitors, of encounters, even if most pass quietly unnoticed. And you resting here are part of a solar system drifting through a galaxy full of wanderers. Some you will see, most you will never know, but all of them whisper the same truth. The universe is alive with motion. Nothing stays still. Every object is on a journey. Let that awareness soothe you. Let it remind you that in this vast, quiet cosmos, even worlds wander. And every wanderer, every rogue planet, every interstellar shard is a sign of the universe's restless beauty, quantum foundations of the universe. In the quiet hours of the night, when the world softens and thought drifts like slow-moving fog, the universe reveals a different face. Not the vast cosmos of galaxies and dark matter and colliding stars, but the hidden machinery beneath it all. A realm so small, so delicate, so impossible to see directly, that everything we know emerges from its restless whisper. This is the quantum foundation of the universe, the place where emptiness is alive, where particles flicker in and out of being, and where space and time themselves may be woven from something deeper, the vacuum that isn't empty. When you imagine emptiness, you might picture a quiet void, a dark, silent expanse with nothing to disturb its stillness. But the quantum vacuum is nothing like that. Even at its calmest, space heaves with invisible motion. Tiny fluctuations ripple through fields that fill all of reality. Virtual particles, brief sparks of existence appear, interact and vanish again before any detector can trap them. They behave like ghost notes in the cosmic symphony, fleeting, ephemeral, but essential. Their presence affects the strength of forces, the energy of atoms, and even the expansion of the entire universe. A vacuum, the simplest, quietest thing we can imagine, is in truth one of the most vibrant and mysterious. Particles born from nothing. Quantum theory tells us that particles can emerge from emptiness itself. Not from a place, not from a cause, but from the uncertainty baked into the fabric of reality. These particles are not stable citizens of the universe. They flicker like fireflies in a storm, glowing for an instant before dissolving again. Yet collectively, they leave fingerprints on everything, shifting energy levels in atoms, altering the force between charged plates, shaping the temperature of black holes, contributing to the energy of the cosmos itself. They are the quiet laborers of the microscopic world, building and unbuilding reality billions of times each second. Space is something that emerges. In ordinary life, space feels fundamental, a stage where matter stands, where planets spin, where time unfolds. But modern physics whispers another possibility, that space may not be the foundation, but the product of something deeper. Some theories imagine space as a vast network of connections, like threads, woven into a tapestry of relationships and quantum information. Zoom in far enough, and the smoothness dissolves, replaced by discrete units like pixels forming a picture. Distance itself could be nothing more than the strength of connections between these underlying building blocks. Geometry, the shape of the universe, could emerge the way temperature emerges from the motion of microscopic molecules. In this view, reality is not built from things, but from relationships. A cosmos made not of objects, but of information. The seeds of cosmic structure. In the earliest moments of the universe, quantum fluctuations, tiny ripples in energy, were stretched across the cosmos by rapid expansion. Those ripples became the first clumps of matter, the webs of galaxies, the giant voids and filaments, the entire scaffolding of the observable universe. Imagine that every galaxy, every star, every planet, every world began as a tremble in the smallest possible domain. The structure of everything you see in the night sky comes from uncertainty itself. The hidden quantum states of reality. Quantum fields can exist in many different possible states, some stable, some delicate, some so subtle we cannot even define them with current mathematics. The vacuum we experience might be only one choice among countless possibilities. Other states could exist with different particle masses, with different strengths of gravity, with different laws altogether. They might span distant cosmic regions or lie dormant beneath the surface of our reality, influencing processes with a whisper too faint for us to detect. Perhaps the universe sits atop a landscape of possible quantum realities, a plateau among mountains, valleys, and seas of unknown configurations, where quantum theory and gravity meet gravity governs planets, stars, and galaxies. Quantum physics governs atoms, fields, and the smallest particles, yet the two refuse to merge smoothly. Their principles collide, diverge, and break down in extremes in black holes in the earliest moments of time, in places where space curves so sharply that classical ideas dissolve. At those edges, time may not flow normally, space might lose its meaning, fluctuations become violent, geometry trembles. These places, quantum gravity frontiers, are the borders of the knowable. Physicists speak of loops, strings, holograms, networks, quantum foam, each a different attempt to describe the same truth. Somewhere far beneath what we can see, the laws of physics unify into a single, elegant, and still hidden reality. A soft reflection on the unseen tonight. As you rest, imagine the universe not as stars and galaxies, but as shimmering fields extending everywhere, even through you. Imagine reality as a soft fabric vibrating gently, producing particles the way a pond produces ripples when touched by falling rain. Imagine space as a quiet ocean, and quantum fluctuations as tiny waves forever rising and falling. You are made of those waves. Everything is. The chair beneath you, the atoms in your breath, the distant stars humming in the night, all of them shaped by ghost-like particles shifting, vacuum energy, and hidden structures beneath the surface of being. When you breathe out and let your thoughts soften, you are drifting closer to that foundation, to the quiet, restless, shimmering core of the universe. The quantum world is not chaotic. It is intricate, delicate, profoundly calm at its deepest level. A meditation in physics, a whisper beneath existence, and it holds everything. Life informs. We have never imagined life as we know it is only one letter in an alphabet the universe has barely begun to whisper. We look for water, for carbon, for familiar chemistry because we know those pathways. We search for blue skies, warm oceans, and gentle atmospheres because that is where our story began. But the cosmos does not owe us familiarity. Life may be far older, far stranger, and far more adaptable than anything Earth has ever taught us. Tonight, we drift into that possibility, into a universe where life blooms in places we would never expect, where biology bends in directions we cannot predict, and where the spark of living systems might be woven through cosmic darkness, like seeds waiting for the right conditions to awaken. Life in impossible places. On Earth, we find life in boiling vents, in frozen deserts, in radioactive pools, in acid lakes, even in the vacuum of space momentarily clinging to the hull of the space station. If life can thrive in places that seem utterly hostile, what might be possible under alien skies? Imagine organisms whose cells do not need liquid water, but liquid methane like on Titan's frigid lakes. Imagine microbes that breathe hydrogen, or exhale sulfur, or thrive at pressures that would crush steel. Life might not need warmth. It might arise among icy shadows in caves of ammonia frost, or beneath crusts of frozen nitrogen. The universe is full of extremes, and every extreme is a potential home. Exotic chemistry, life that breaks the rules. Our biology clings to carbon, but the periodic table is large. Chemistry is creative. Scientists imagine life built from silicon chains instead of carbon, solvents like methane or liquid nitrogen, membranes made from exotic polymers, structures stable only under crushing pressure, biological reactions driven by radiation or magnetism. At temperatures where our DNA would shatter, other molecules could become stable, flexible, alive. What feels impossible here might be natural elsewhere. Some life might be metallic, crystalline, or semi-fluid, strange to us but harmonious within its native environment. Life, after all, is not a shape or a substance. It is a process, self-maintenance, adaptation, energy pattern, memory. Those processes may thrive under conditions we would call unimaginable. Worlds that don't need planets. We often assume life requires a planet, a surface, an ocean, a comforting star. But what if life does not care about any of those things? Inside gas giants, deep in warm atmospheric layers, complex chemistry might swirl into organized systems floating like jellyfish in thick clouds of exotic matter. On rogue planets drifting between stars, geothermal heat could maintain subsurface oceans beneath icy crusts, creating warm, dark seas filled with chemical energy. Even in interstellar space within dust-filled clouds on the surfaces of grains or inside slow-moving icy conglomerates, primitive biochemical cycles could arise powered by cosmic rays or faint thermal gradients. Life might not need sunlight. It may not need a star at all. It may not need a home, just the right conditions to begin its quiet work. Alien ecosystems beyond recognition. Now imagine not just life, but worlds full of life ecosystems utterly unrelated to Earth. Forests of slow-moving silicate towers absorbing magnetic energy. Oceans filled with translucent organisms drifting like living lanterns. Atmospheres with airborne microbial swarms feeding on lightning-produced ions. Rocky surfaces where biology emerges from mineral networks rather than organic tissue. On worlds with perpetual night creatures may evolve senses we cannot conceive: magnetic vision, electric perception, pressure-based navigation, chemical hearing. On tidally locked planets, ecosystems may grow in thin twilight bands where day and night meet neither too hot nor too cold, a sliver of eternal dawn filled with life adapted to narrow margins. Evolution is not gentle, it is inventive. Every environment shapes new strategies, new forms, new ways to thrive. Biosignatures, we don't recognize our telescopes search for oxygen, methane, water, vapor, signs of life as we know it. But alien life might leave behind gases unknown to Earth, strange heat patterns in the infrared, minerals rearranged into geometric structures, pigments that reflect unusual wavelengths, chemical ratios that no geology can produce. Life might hide in signals we once dismissed as noise. It may exist in atmospheres we considered sterile. It may be whispering to us already in patterns we don't yet understand. To find it, we must be willing to look with new eyes to accept the possibility of the unfamiliar. Evolution in ways we cannot predict. Life on Earth inherited DNA. Another world might inherit something else: crystalline information, magnetic codes, fluid patterns, quantum states passed between molecular lattices. Evolution could proceed through self-assembling networks, shifting collective behaviors, chemical colonies acting as one, life cycles that span centuries or millennia, organisms that dissolve and reform in new shapes. Some life might be slow, too slow for us to see movement. Some might be fast, faster than any terrestrial biology. Some might never evolve intelligence as we know it. Others might surpass us in ways we have no language to describe. A soft reflection. Hope in the wider universe. As you relax deeper into this quiet moment, consider the smallness of Earth, a single world among trillions. Yet life found its way here. From oceans to forests, from bacteria to galaxies of thought, it blossomed. If life could arise here against all the odds, from stardust, from chemistry, from chance, then surely it can arise elsewhere. There is something comforting in that idea, something warm, something profoundly human. We are not the universe waking up for the first time. We are one of many awakenings, one expression among countless possibilities. Somewhere right now in a distant cluster or a quiet cloud of dust, life may be beginning softly, slowly, quietly under alien skies. And one day we may learn its stories. Until then, let this thought cradle you. Life is not rare. Life is not fragile. Life is creative, stubborn, restless. It seeks every crack in the cosmic pavement, every drop of warmth, every chance to bloom. And the universe, vast, cold, ancient, is full of places where it might be waiting. And now, as our long journey comes to a close, the universe grows quiet again. The galaxies dim, the interstellar winds soften, and the immense architecture of reality settles into a gentle hush. We have wandered across horizons and oceans of time, from quantum whispers to drifting rogue worlds, from the hidden currents between stars to the strange possibilities of life beyond imagination. And through it all, one truth has followed us like a soft, steady light. The cosmos is vast, mysterious, and endlessly patient. It asks nothing of you. It demands nothing. It simply is a calm, ancient presence stretching across the night. A soft return from the infinite. Let yourself drift slowly back from the edge of the universe, past the wandering planets and the invisible architecture of interstellar space, past the cold frontier of the solar system and the bright orbits of the inner worlds, past the thin blue glow of our atmosphere and down to the quiet room where you lie now. You have traveled farther than any spacecraft will in your lifetime, and yet you've returned without strain, safe, warm, grounded. Tonight, you've stood on the boundary of everything, looked out across the deep dark, and felt the calm that comes from knowing the universe is so much larger than your worries. A moment of gratitude. Thank you for coming with me, for letting your imagination stretch across billions of years and trillions of miles, for listening gently, patiently, openly. Every time you press play, every time you join me for one of these slow journeys, you become part of a small constellation of curious, quiet minds exploring the dark together, and I'm grateful truly to share this space with you. Let the universe hold the rest. As you settle into sleep, let the weight of the day fall away. Let the distant galaxies carry the thoughts you no longer need. Let the soft glow of starlight cradle your mind the way it has cradled worlds for billions of years. You do not need to solve anything now. You do not need to reach or grasp or plan. The universe can hold all of that for a while. All you need to do is breathe, slowly, gently, like the rhythm of orbits, like the turning of galaxies, like the rise and fall of tides in distant nebulae, a final whisper into the night. Wherever you are, whatever time it is, you are a small warm moment in a vast peaceful cosmos, and tonight as the stars drift above you, as the dark sky settles like a blanket, as your thoughts soften and dissolve into stillness, you are allowed to rest. Thank you for listening. Thank you for traveling with me. Sleep well and let the universe keep watch.